Hey, and welcome to Building Blackjack. I'm so excited about this one because you are going to learn JavaScript while building one of the most iconic casino games ever. Here is a sneak peek of the app we are going to build, and while it's not a full-blown Blackjack app, of course, it does share a lot of the functionalities with Blackjack apps you can play on online casinos. And speaking of that, that is actually a huge market. People spend over $20 billion per year gambling on online casinos. And personally, I love playing poker and blackjack. I think my life actually peaked when I won €100 on a casino in Prague in 2016. That made me feel like such a gangster. I spent the rest of the weekend squatting in front of fast cars, like this Mercedes, this Hummer, this BMW, and this Bentley. So my goal with this section, of course, is to make you feel as cool as I did in 2016. And with that out of the way, let's just get started. Or actually, before we move on, I want to tell you a little bit about the live events we arrange here at Scrimba. Because as you are progressing into the land of JavaScript, you will probably find yourself struggling at times. What you are learning is challenging, so you might find your motivation vary from time to time. And to pick you up and get you going again when your motivation falls, we are arranging a bunch of cool happenings throughout the week, every single week here at Scrimba. For example, we have live streams on YouTube where we interview domain experts where you can show up and ask questions to these amazing guests, like for example Kevin Powell, who recently came onto our YouTube channel and talked about the new and awesome things that are happening in CSS. Also, we have coding challenges that you can join alongside the community to test your skills. They are hosted and created by Leanne, and she has a live stream, the weekly web dev show, where she looks through the submissions and announces the winner of the competition, voted up by you and the rest of the community. Also, Leanne and Michael and Pumpkin regularly go live on YouTube where they code these solutions out with the community. And personally, I myself host a weekly event on Thursdays. It's the weekly community meeting where you can show up and connect with other students here on Scrimba, ask questions, and in general just get inspired. And also we have fireside chats where we bring on a panel of experts and discuss a certain topic related to learning to code and getting your first developer job. So these events are here to support you. You should definitely not join all of them. You should spend more time coding than joining events, but you should cherry pick the ones that you think are interesting and the ones that can help you when your motivation is low or when you are confused. So you might wonder, where can I find all of these events? And luckily, on your dashboard, if you scroll a bit down, you'll see that there's a widget called Upcoming Events, where you can click on each of the events that are coming up this week, and you are taken to the relevant page for that event. Also, if you hover over the timestamp here, you'll see the timestamp in a bunch of different time zones. Now, a lot of these are recorded as well, so if you can't show up, most likely you'll find a recording after the event has happened. We are, of course, sharing all of this information on Discord as well. So if you click this image right here, you'll be taken to the announcement channel where we always share the given event before we go live. So keep an eye out on your dashboard and the announcements channel and take advantage of these events so that you maximize your chance of getting through this career path and becoming a professional web developer. With that, let's move on. Okay, so we're going to kick this off with a challenge. You are going to create two variables, the first card and the second card. Then you're going to set their values to a random number between 2 and 11, as that's the values you can draw from the deck of cards in Blackjack. Secondly, you are going to create a variable sum and set it to the sum of the two cards. So go ahead and do this right now. Okay, let's do this. Start with the first card. I'm going to set it to 6, and the second card up to 9. Then the sum, of course, equals first card plus second card, like that. Let console log out the sum, run the code, and yes, indeed, we get 15. Great job. Let's move on. Okay, so we are ready to build the logic of our Blackjack game. Now, let's have a look at how Blackjack works before we try to formulate this in JavaScript. So the point with blackjack is to get a hand that sums up to exactly 21. And if you don't get 21, at least you want to get as close to 21 as possible, but never above 21, because if so, you're out of the game. So here are 3 scenarios. One where you have 2 cards on your hand, that's your starting hand, and they amount to 15, so you're still in the game. No big reason to either cry or celebrate. Then there's the other case where you have a king and an ace. And since the ace here equals 11, and the king equals 10, you've got blackjack. So, woohoo! And the third scenario, you started out with a 10 and a 6, and then you asked for a new card, but damn, you ended up at 22. So you're over 21, and sadly, you've lost your money. So now the question is, how do we translate these things into JavaScript? Sadly, JavaScript isn't as smart as you are, who can understand this by just hearing me talk about it. JavaScript is kind of stupid, and it needs you to describe the logic 100% correct. So let's just do that so you get to see it in action. We start out with writing if, and then open and close parentheses, and then it's the sum of our cards that we're going to check. So we say if sum is less than 21, just like we were doing here. So this crocodile mouth is something you might recognize from your maths class at school. And it kind of makes sense because here on the right hand side, you can see that's where the gap between the teeth of the alligator is the largest. Whereas at the left hand side here, the gap between the teeth is the smallest. So small value here, large value here. If this condition is true, meaning that sum is less than 21, well then we add 2 curly brackets and tell JavaScript that we want to execute the piece of code inside of those curly brackets. So we'll do console log. Do you want to draw a new card? Since that's what you can do in this scenario, you are still in the game and you can draw another card if you want to. But there are cases where this isn't true and we need to account for those as well. We do that by writing else if and open and close parentheses. And here we write sum equal 21. This is else if sum equals 21. Then we want this code to be executed. And this triple equal operator is different from this one right here. Here we are saying that we want the sum to become first card plus second card. But here we're asking, is the sum strictly equal to 21? And you say strictly equal when you see 3 equal marks. And don't worry about why it's 3 and not necessarily 2. We're going to get back to that later. For now on, just use 3 equal marks when you write else if statements where you are checking if a variable is exactly some kind of value. So if the sum is 21, what is the case then? Well, woohoo! The player has blackjack. So we'll do console log. Woohoo! You've got blackjack, like that. And then the third scenario, we'll do else if yet again, sum. And what do you think we'll use here? Of course, we'll use this one right here. Because if the sum is larger than 21, then the user has lost. Sum is greater than 21, open and closed curly brackets, console log. You're out of the game. Like that. Actually, let's add these emojis as well. There we go. Now, one little thing I want you to notice here is that here I have to use double quotes to wrap this, as I'm using single quotes to create this you've and your words. Because if I was using single quotes here, it would be completely off, because JavaScript would have thought that I was intending to close off this string right here, when I'm not intending that. I was just writing you've instead of you have. So just a little digression there. Now let's run this code and see how it works. We'll hit run, and yes, do you want to draw a new card? We triggered this, which seems correct since 9 plus 6 is 15, and that is indeed less than 21. Let's try to do 10 and 11. So this is blackjack. Yes! JavaScript triggered line 8, which is what we wanted. And finally, let's say that we got 17 on the first 2 cards and we really wanted a new card. We wanted to take the chance, but we bummed out by getting 6. If so, our sum would be 23. And what do you think will happen? Yes, this line of code should be run. I'm going to run the code and boom, you're out of the game. Now, a final thing I want to tell you about before we move on is that we could actually skip all of this code if we wanted to and do like that. Because if sum is not less than 21, and it's not exactly 21 either, meaning we've jumped to the third clause in our if-else clause, then it must be over 21. I mean, there's no other alternative in the entire universe. So there's no point specifying that some here should be over 21 for this block of code to be executed. Meaning we can just skip it. So that we have if sum is less than 21, execute this. If sum is exactly 21, execute that. And in all other cases, execute this. This will work, as you see, by running the code in the exact same way. Okay, now that you know that, let's move on. You are to check if a person is old enough to enter the nightclub, which has a lower age limit at 21. And then you are to log a suitable message to the console in both cases. And by that, I mean if the user is less than 21 or if the user is 21 or older. So I've defined the age variable here and also written pseudocode. If less than 21, then a suitable message would be, for example, you cannot enter the club. Else, meaning all other cases, because if they're not less than 21, well, they have to be 21 or above, then you are to log something like welcome. Go ahead and give this a shot. And if you have forgotten how to write an if-else statement, just go back and rewatch the previous lesson. And notice here that I don't have an else-if statement in between here. I only have the first if and the final else, not the else-if which we had in the previous lesson. And that is because I want you to think for yourself and try to figure out, well, how do you write this with only an if and an else, and not the if-else in between? Just give it a shot, and I will show you the solution as well when you return back to this screencast. Okay, hopefully that went well. Let's do this. If less than 21, we have to do age is less. Remember this alligator mouth here. And 21, like that. This means the person is maximum 20 years old. Then we are to do following, well, console.log. You cannot enter the club. And then we simply do else, and then the open and close curly brackets. And here we can console log welcome. Running the code, we get welcome, that's correct. Trying to lower the age to 20, we get you cannot enter the club. Now, a final thing I want to point out is that you could also solve this by using another comparison operator, which is the less than or equal to. That means a slightly different thing though, because it checks that this value is less than or equal to 21. So if we take this back to 21 and run it, you can see we get you cannot enter the club, which obviously is wrong. They should be able to enter the club at this point. So if we're using the smaller than or equal to operator, we have to use 20, because then we include 20. That is an upper range that is inclusive of that number. So now it works. Whether you prefer using less than or equal to or just the less than is up to you. You just need to keep in mind how that changes the entire expression. With that, let's move on. Let's practice if-else statements a bit more. Because in Norway, we have this super cool tradition where when you reach 100 years old, you get a personal birthday card from the king. This is the king, King Harald V of Norway. And in this challenge, we are going to code the logic for this. So here it is in pseudocode. If less than 100, and here I'm talking about the age variable, of course, then you are to log something like not eligible to the console. Else if the age variable is exactly 100, you are to log something like here is your birthday card from the king. And else, in all other cases, meaning they're over 100 years old, you get not eligible. You have already gotten one, because if they're 105 years old, they got their birthday card from the king 5 years ago. Okay, go ahead and give this one a shot, and then I will show you the solution afterwards as well. Okay, let's do this. If age is less than 100, we'll console log not eligible, and then we have to do the else if and specify the condition. Age is exactly 100, then we console log here is your birthday card from the king. And else, in all other cases, the person is over 100 years old, they have already gotten their card, their previous birthday, so not eligible. Let's run the code. Yes, 100, you are getting the card. At 45, you are not eligible. At 145, you are not eligible either. Finally, before you leave, let's take a closer look at this triple equals here, because it might seem like a little bit of an overkill to have 3 equal signs after each other. And that is a valid point. You could use 2. If we run the code, it still works with 145, and actually with 100 as well, it would still work. You are getting your birthday card. However, the thing with 2 equals, so-called double equals, is that it's a little less strict. So let's say that you by mistake passed in a string here as well, which has the same value of 100, but it's a string and not a number. If we run the code, you can see it still works. However, with the triple equals, running the code, then it doesn't work. Now it says not eligible, even though 100 is here as a number and 100 is here as a string. So double equals ignores the fact that this is a string and this is a number. Basically converts this into a number if it's a number on the left-hand side as well, so that this entire thing would be true. However, that's not what we want. We actually want to be strict in our code, which is why I would recommend you to only use triple equals. Ignore double equals. This forces you as a developer to be a bit more mindful about how you are checking your conditionals. You need to make sure that if you're starting out with a number up here, you're also comparing it with a number down in the conditional. But that's just good practice, being thoughtful as to what kind of data type you are using in your code. Just stick with triple equals and you'll be just fine. With that, let's move on. Okay, so now we're back at our blackjack game, and you might have noticed that we've lost the code that we previously had. Well, that's the point of Scrimba. You are going to write the code, not me. So, I want you to rewrite the conditional that I created previously, but with a slightly different take. You have to follow the logic that I lay out in the pseudocode here. So you have to use in the first if clause the less than or equal to operator. So you have to set it to less than or equal to 20. And then in the else if clause, you can use the strictly equal to check if the sum is exactly 21. And finally, you're going to use the else clause and not an else if on the third conditional, which I did previously. So go ahead and do this. And if you can't do it or want to see my solution, just return back to the screencast and I will show you how to do it as well. Good luck. Okay, let's do this. First, there's the if sum is less than or equal to 20, then we are console logging out this string right here. And then we do else if, the same as we did last time, sum triple equals 21. That's the blackjack case. And here I'm lazy, so I'll just copy paste this one and then this one in here. And then finally, not doing else if and checking for the condition, but just doing the else. So all other cases. And then pasting in this, you are out of the game string like that. Good stuff. Let's run the code. And yes, we have 17 here and we rightfully so logged out. Do you want to draw a new card? Good stuff. If we try to hit one more time with another 10, we are out of the game. Good stuff. And how about a 4? Blackjack. Woohoo! Great job. Let's move on. Okay, so our game is coming along really nicely here. However, there's a big problem. And that is, let's say that you are playing this game and you get blackjack. So you get a 10 and an ace. And boom, you've got blackjack. And down here at line 13, you of course want to cash out your money. You want to get the pot on the table. However, at this point, down on line 13, JavaScript has no way of knowing which console log it logged out. It doesn't remember that. So what we need to do then is introduce a new variable that keeps track of this state, you can call it, the state of the game. Like, has the user gotten blackjack, or maybe has the user lost, or whatever it is. So what we then want to do is, for this scenario, have a variable that reflects whether or not the player has blackjack. And when I say whether or not, yes or no, is there a data type in JavaScript that you think might be suitable for describing such a state? If you guessed a boolean, a true or false, that is correct. So what we'll do is we'll do let has blackjack like that, and set that initial value, of course, to false, because by default you don't have blackjack. And then here inside of the else if clause that describes the blackjack case, we're simply going to reassign the has blackjack value to true instead. Now, down at line 16, if we log this out, the has blackjack value, and then run this code, boom, you can see that we're both logging out on line 9, and we have persisted the state so that line 16, for example, can start writing the code for taking the cash that's on the table that now is rightfully yours and then deposit it into your account. So now we have an app that keeps track of the data of the state in a much more sensible way. Now I want you, of course, to write this kind of logic yourself. So in the next cast, I'm going to give you another challenge so that we can keep track of even more of the state of this game. I'll see you there. Okay, so now it's your turn, and you are going to make the state of our game a little bit more robust. Because at this point, we're only tracking if the player actually gets blackjack. If the player busts out and gets 22 or more, we're not tracking it, and obviously we have to do that. So I want you to create a variable called isAlive, and start by assigning it to true, and then you're going to flip that value to false inside of the appropriate code block. So there's 3 code blocks: the if block, the else if block, and the else block. And you of course then have to pick the correct code block and then write that line of code that flips the value to false. And finally, log it out to check that you're doing everything correctly. So good luck, go ahead and do this, and then I will show you the solution afterwards as well. Okay, let's do this. Starting up here, we're going to create a let variable called isAlive and assign that to true, because when you're starting out, the player is still alive, and at which point is the player no longer alive, meaning out of the game? Well, that's obviously here in the else block, because that's the case if the sum is 22 or more. So here we'll do isAlive equals false. And then finally, we'll console log isAlive, like that. We got true because actually we had blackjack, and rightfully so, the player is not dead. How about if we pretend that we add a third card here? It's a really stupid idea. Pick a third card after you've gotten blackjack, but let's just pretend that. We'll run the code, and boom, false, no longer alive. Great job solving this challenge. Let's keep up the pace and move on. Now that you've learned about booleans, let's take a look back at the conditional you wrote. Because one thing you probably didn't think too much about when you wrote your conditionals is that the expressions inside of the parentheses would be translated by JavaScript eventually into a boolean. So it would be either true or false. That's always the case with expressions passed into conditionals. Because here we are comparing 2 numbers, and one of them are either larger than the other or they are 2 equal numbers. So the claim you come with has to be either true or false. Let's try to play this out using an example. For example, when you've gotten 2 cards, a 10 and an 11, meaning you have blackjack. In that case, sum will be 21. And the claim you come with inside of the first if statement, obviously that is a lie, meaning it gets evaluated to false. In the second condition, though, you're saying that sum is equal to 21, and we know we are going to translate sum into 21 because that's what it is. So here you're saying 21 triple equals 21. Well, yes, that is a true statement, so that becomes the true boolean. And here you can read through it. If false, well, then we're going to skip the body of this statement. Else, if true, yes, we like true, then we are going to execute that piece of code. So this is essentially what happens when you run the code with specific values for these variables. Rewinding it back, what I want to do now is stress test your comparison and Boolean skills. So I'm going to paste in a bunch of console logs here and then comment out our blackjack game. Now your job is to look at each of these expressions and predict whether true or false is logged to the console. So write either true or false after these 2 slashes on each of the lines from 1 to 7, And then, of course, when you've given it a shot, run the code and see how it went. And then I will do the same thing afterwards as well. Go ahead and do this right now. Okay, let's do this. First, 4 triple equals 3. Obviously, that's wrong. It's going to log out false. 5 is greater than 2. That is true. And 12 is greater than 12. No, 12 is not greater than 12. It's exactly the same. So this will be a false statement. 3 is less than 0. Again, that's also false. 3 is larger than or equal to 3. Yes, that will be a true statement because it's not larger than, but it is equal to. So true. 11 is less or equal to 11. Again, it's not less than 11, but it is equal to 11, so it's true. And 3 is less or equal to 2. No, 3 is actually larger than 2, meaning that this is going to be false. So this is my prediction. Let's run the code, bring up the console, and yes, phew, I was right. Very good. Let's move on. Welcome back, my friend. I hope you are ready for a new challenge, because that is exactly what I have in store for you now. Actually, it's a 3-part challenge, because you are going to make our program a little bit more robust in the sense that it might be that these console logs here that we're just throwing out into the void, logging to the console and forgetting all about, can be used later on down the line, or that we, of some reason, want to keep track of them. Maybe we want to render it out at multiple locations in the app. Maybe there's a notification and there's text, there's a log of messages you've gotten. Maybe we want to repeat it. I don't know. There's tons of reasons for keeping this data and very few reasons for just logging it out. We want to keep it in a variable, just like we've done here with the has blackjack and is alive. So your 3-part challenge is to first declare a variable called message, and then assign its value to an empty string, and then you're going to reassign the message variable to the string we're logging out. Notice here that I'm using some fancy words, like I'm saying declare instead of create a variable. I'm saying assign instead of set its value. That's because I think you now are ready to hear some of these fancy JavaScript words, because there are subtle differences between these words. Like here we are actually declaring the variable, and then we are assigning it when we set the value to true. This is, after all, called the assignment operator in JavaScript. And then, naturally so, when we change a variable or assign it yet again, we reassign it. So I just want to use the correct terminology here. But I think it's important that you don't get put off by all of these words and think that you have to remember them all. You do not. It's perfectly fine to talk about this using your own words. Create, change, set the value, whatever. I just want you to also be exposed to these technically correct ways of expressing it. Anyway, enough talk. As I said, step 2, you are going to reassign the message variable to the string that we're logging out. So I don't want any more console logs inside of these 3 code blocks, because the only code block is the one you're going to create in part 3 of the challenge when you're going to log out the message variable. So go ahead and give this your best shot and then return back to this screencast when you want to see my solution. Okay, hopefully that went well. If not, no worries, let's do this together. First, we'll start by declaring this let variable. We'll call it message, and we'll set it to an empty string. Then, on line 11, 13, and 16, we need to replace the console log with a message equals, like that. And also remove this close parentheses. Do the same thing here. Remove this one and the close parentheses, and then write message equals. Finally, here as well. And then we are ready to log it out down here at line 21. So I'll log out the message, run the code, and as you can see, we're logging you are out of the game. That is correct because we had this really stupid move where we got blackjack, but we asked for a new card. So let's remove this, run the code. Yes, you have blackjack. And again, with, for example, 14, and yes, I can now draw a new card. So, great job reaching this far. Let's move on. Okay, now it's time to fix our biggest flaw in our blackjack game, which is that it has no user interface. If we want this to be a hugely successful online blackjack game, it has to use HTML and CSS so that users can play it via a browser. And I've actually set up the basics for you here. You can see an HTML file with a head and a body, and then inside of the body we have an H1 with the text blackjack, and also we are linking to the JavaScript file here on line 8. And as you can see, if we bring up the mini browser, this just renders out the H1 tag. So your job now is to link this HTML file to the CSS file. You can see I've created just one CSS rule in this file, and it will be applied, changing the color of the title when you manage to add a link to the CSS file here on line 5. So I almost every single time have to search on Google for how to link to CSS from HTML. I end up at something like this. So I want you to do the same thing. And one tip would be to find this W3 schools right here, as they often pop up on Google and contain the necessary information. So go ahead and figure this out on your own, and then I will show you the solution afterwards as well. Okay, hopefully you nailed that one. If not, no worries. Let's first check out Google. Then if we click into the W3 Schools site, you'll see the following. And it tells us that there are 3 ways to insert CSS: external, internal, and inline. And we are using an external CSS file, so we want to scroll down to external CSS. If we do that, we see the code here, and the line we're looking for is this one: link rel equals stylesheet, href equals mystyle.css. Okay, good. So let's do link rel, and that is short for relation. So what is the relation between this HTML file and the current file you're going to point to now? Well, it is that the file you are pointing to is a style sheet. Because as you remember, CSS is short for cascading style sheets. And then it is the href, which in our case is index.css. We are in the same directory, so you don't need to navigate into a folder or anything like that. We'll just write index.css. And the href attribute is something you should be familiar with by now, as that's also what we use when we are creating links. Now, let's run this code. Boom! You can see the color has changed, meaning we are indeed importing this style sheet. Great job! Okay, now it's time for you to style this app, because as you can see, it looks kind of bad. I've added a few more paragraphs here, as you can see. One which says want to play around and has an ID of message shell, and then just 2 other paragraphs that will display the cards and the sum eventually. And your job now is to take this HTML and make it look like this. If we head into the index.css file, you can see it says complete the CSS styling according to the provided design. And here I've created 2 new selectors for you, the body and the message shell. And the thing is, you can create this entire design by only using these 2 selectors. So that's why I have them here for you. I've also added a table.png inside of an images folder. That is for the casino background that we are using here. And you've learned all about how to do this styling in previous modules of the career path. So if you struggle, you can go back and rewatch some of those lectures if you want. Now, before you start solving this challenge, I'm going to add the font family for you, because we're using the trebuchet font here, and you haven't really learned how to do that, so I'm going to do it for you. We do font family up in the body, and there I specify trebuchet. And as you noticed, what happened now was that the editor gave me a bunch of other fonts as well. And this is called a font stack. And the reason we use font stacks is because if your operating system doesn't have trebuchet MS installed, well, then your browser can't show that font unless you've also imported it from Google Fonts, for example, or included it in your project, neither of which we have done right now. So if your operating system can't show trebuchet MS, then we're telling it to look for Lucia Sans Unicode then. And if you don't have that either, well, look for Lucia Grande, and so on and so on. So it kind of ensures that at least we'll find a somewhat similar font. As it moves downwards in the stack, it'll at least find a sans serif font here, which is our final choice. But let's stop with fonts there. I don't want to get deeper into it. Now we have the trebuchet font visible, and hopefully it's visible on your end as well, because trebuchet is one of those fonts that are so-called web safe, meaning that almost all operating systems have them installed, so it's safe to use. Now I want you to take a look at this design and add whatever CSS you need to the body and the message shell, so that you turn this boring page into what looks much more like a real blackjack game. So go ahead and do this right now. Okay, hopefully that went well. I'm going to start with the background image. So I'm going to write background image. And then fetch this table.png here. I can do URL, open and close parentheses. Then navigate into the images folder and grab a hold of the table.png. Like that. Now you can see we have the nice background. However, if I drag this wide, you can see that at some point we reach the end of the image and CSS adds the image yet again after that. We get this ugly looking line which we don't want. We instead want to use the background size property and set that to cover. Now, no matter how wide we make it, the image still covers the full width. Okay, next step is to center this text and make it white. So we can do text align center to center everything and color white like that. So with this, we are turning everything into white except for the H1, which you can see here we have specifically specified that the H1 should be color goldenrod, and that overwrites the color white on the body element. Next up, you can see here the text is a bit bolder, so we want to do that as well. We want to do font weight bold like that. Starting to look good. There's just one final thing, just that you can see the message element, which is the message for the user, is in italic. Here it's still just normal. So in the message cell, we'll do font style and set that to italic like that. And there we have a neat looking blackjack game. So with that, let's move on. Okay, so now we need to enable our user to click a button to play the game. And you are going to do this through a challenge, of course. And I'm really excited about this one because it includes both HTML, CSS, and JavaScript. So this is the first time where you'll use all three languages to solve a problem. And the reason that this is so cool is because this is how it works in real life. When you get a job as a professional developer, you'll juggle between HTML, CSS, and JavaScript all the time. And this is an opportunity to start practicing exactly that. So it's a three-part challenge, starting here in the HTML, where you are going to create a button that says Start Game. And it should call a Start Game function when it's clicked. So obviously, then you also need to create that Start Game function. We'll do that in the index.js. Here we are to create the Start Game function and move the conditional below, line 11 to 20, that's these lines, into the body of the function, so that this code is run when the button is clicked. And then finally, you have to make the button look good for the user. You are going to style it according to the provided design. And that is exactly here. You can see the start button. So just click to open this slide whenever you need to take another look at it. And doing this, translating a design into CSS, is something the front-end developers do every single day. So it's great practice. I've given you three values for properties here. There's the color of the text. That should have this hex value. The width should be 150 pixels. And the background should be goldenrod. Same as the text color on the H1. This is a big one, so I can totally understand if you'll struggle a bit going through this one. But give it your best shot and then return to this screencast when you want to see my solution. Good luck. Okay, hopefully that went well. Now, let's do this. Here, we'll do button, like that, opening tag, and then I'll do the closing tag as well. And inside, we'll write start game, like that. Let's run the code, and it looks not particularly good, but it's at least there, and it's actually centered. The reason for that is because here on the body, we are centering all of our text, and that also centers the button. Next up, we need to call the start game function when it's clicked, and if you remember how that was, then you'd write onClick equals, and then the start game with open and close parentheses inside of a string right here. So when the button is clicked, we're going to call or invoke the start game function. Then we need to create that function, and if you remember how to do that, it is through the function keyword, function, and start game, open and close parentheses, and then curly brackets for the body of the function. Inside of here, we are going to take this code, copy it, paste it in. I'm going to give it a tab so that it looks better, like that, and remove the empty lines. Now we have this. Let's rerun the code and see if it works. Yes! Previously, we got this console log just by refreshing the page, but that doesn't happen now. I have to actually click the start game, then we run this, then we console log out the message. Great job. Now let's move on to the CSS. Okay, this is how we want it to look. Let's take the first 3 provided design hints and see how close we get just by implementing them. Text color, that is the color property. Like that. You can hardly see it since the text is so thin, but that's okay for now. Let's just set the width with 150 pixels, like that. Okay, looks a little bit better. And the background, that should be goldenrod. Okay, so looking a little bit better, but not quite this design here. As you can see, it has some space above and below the text, whereas this one is much more crammed. So let's add that. And if you remember from the CSS section, you could add that space by using the padding. So that's padding top and padding bottom. I'm going to set 5 pixels. Looks about right. Padding bottom and do 5 pixels there as well. Yeah, not too bad. However, as I mentioned, this text is really thin. And here it's much thicker. So let's actually do font weight bold. Yes, that looks much better. Now, the next thing I want to fix is the border around the button, because you can see it's totally clean here. It has no border, but the default styling that our browser provides has this little border. So we want to do border none. Okay, now it's actually pretty similar. They're almost identical, but only one thing separates them. And that is that you can see the edges are sharp on this one, whereas the edges are a bit rounder on our provided design. So that is the border radius, and pretty subtle. So I'm going to try 2 pixels. And yes, that looks, as far as I can see, identical. So this was a huge challenge, and you had to context switch between HTML, CSS, and JavaScript. So be really proud of yourself for reaching this far. If you struggled and didn't really manage to get to the finish line on your own, I think you should just go back and try it again now that you've seen my solution. That's a great thing to do to reinforce what you've just learned. Whatever you do, I will see you in the next lesson. Okay, so now our player can click the Start Game button like this. However, we're only logging out the message. Obviously, we don't want to do that. We want to display that info on the page, along with, of course, information about the cards and the sum. But starting with the message, I want you to solve a 2-part challenge. First, you are going to store the message L paragraph, that is this one right here, in a variable called message L using the camel case naming convention. And then you're going to display the message using message L.textContent. Then, of course, you can remove the console log right here since we don't need it anymore, as the message will pop up here in our app instead. So go ahead and give this a shot and return back to me when you want to see my solution. Okay, so the way to do this is, if you remember, first by creating a variable with let message L, and then using the document keyword dot get element by ID, passing in the ID, which we can see from the HTML, and just copy from there actually, and paste then in here. As always, console logging to see that we are on the right track. Running this code, and yes, there we can see we are logging out that element. Now it's just a matter of deleting this line, doing message L dot text content, and what do we want to set the text content to? We want to set it to message, like that. If we now run the code, hit the start game button, yes, there we got. Do you want to draw a new card? Great job. Now, there's one thing I want to do before we round off, and that is actually to remove these emojis, because when they are italicized, they don't look that good. And while that isn't the most complicated thing to fix, it's not something I think you should learn right now. I want to keep up the pace. And also, when we see this text here rendered on the page, it's kind of our dealer speaking to us in italic text, and I don't think our dealer should show that much emotion. So it makes sense to remove these emojis like this. And also maybe make it a bit more neutral. The dealer will just tell us that we have blackjack. It won't shout out, woohoo! So Makes more sense. Draw a new card. Yeah, looks good. If we get blackjack, yeah, I think that looks good. So with that, let's move on. Okay, so let's make our game a little bit more useful, because now you can click the Start Game button, and indeed, we get the message from the dealer, but we have no idea what our sum and our cards are, so we obviously need to render that out. And we're going to start with the sum. So it's a 3-part challenge, where you first have to head into the HTML, and there give the sum paragraph, that is this one, an ID of sum-L. Then you are to store the sum paragraph in a variable called sum-L, like this in camel case. And finally, render the sum out. So here I'm talking about the actual numeric sum on the page using this format. So sum, colon, and then the given sum you have up here. So here you have to keep this text, which is already in the DOM, intact. But we have done that before, so hopefully you'll manage it. If not, no worries. You can just revert back to this screencast and I will show you how to do it as well. But go ahead and give this your best shot right now. Okay, let's do this. First, we'll give this an ID of sum-L. Moving over to the JavaScript, we'll do let sum-L with the camel case this time. And do document.get element by ID, open and close parentheses, and the quotes, passing in the ID that we just added to the HTML element, sum-L. Now, just to be certain, let's just console log the sum-L, run the code. Yes, indeed, we are grabbing the element. And then we need to render out the string of sum, and then the actual sum, which in this case is 14, from this variable up here into the element itself. And the way I'll do that is I'll use sum-L and then text content, which you should have seen a few times by now, and set that equal to not only the sum, because if we do that, let's rerun the code and start the game, then we simply just clear out the existing text, whereas we want to keep the sum there, and we can do that in multiple ways. But the way I'll do it is simply just write sum, colon, a space, and then plus here. So that we just reconstruct the default text as well, in addition to the sum. I think this is a nice way of doing it. So if we run the code, start the game, yes, there we go. Now, before we move on, I want to teach you about another way of grabbing elements from the DOM. Because we've used getElementById a few times now, so I'm assuming you're comfortable with this technique and are ready to learn another one. And that is something called the query selector. And to learn that, let's comment out this one and copy it to a new line where we can change it. And here, instead of getElementById, we'll do query selector, like that. Since this is a more dynamic method, we have to be a bit more specific in the value we pass into it. So here, we actually have to pass in a hashtag in front of the sum-L to tell the query selector that it's actually the element with the ID of sum-L that we're looking for. Because unlike the getElementById, we're not specifying that it's an ID in the method name. It's just called query selector, which is kind of a broader expression. So query, that's another word for question, and selector, that refers to CSS selectors. So we're kind of asking for an element by its selector, and then we specify the given selector inside of the parentheses. So here, if we run this, start game, the exact same thing happens. Now, if you've forgotten what a CSS selector is, we can head over to the CSS, and it's these guys right here. The body, that's just selecting the body element, this one. And then there's the ID selector right here. You can see we are using the hashtag to grab the message L, because this paragraph has an ID of message-L. Likewise, sum has an ID as well. So we're using the hashtag to tell query selector that this sum-L comes in the form of an ID. Now, this means that we could change this to a class instead. However, then we also have to change this hashtag and replace it with a dot. Hopefully you remember that the way to select CSS classes is by using the dot. If we run this, it still works. And actually, we could even pass in just the element name as well. So we could do body right here. However, it would break our app since we're now, just clearing out the entire body when we are running this piece of code down here on line 11. Because now SUML actually refers to this entire body. So as you probably understand, query selector is very powerful and you will see it used in a lot of tutorials here on Scrimba. But as for right now, I just wanted to show it to you so that you are prepared once you see it in other tutorials and out in the wild. In the near future, I am going to stick with the document.getElementById, as that does the job for us. And it's also a very simple method to understand. So I'd like to avoid the added complexity of jumping between getElementById and query selector if we can. With that, let's just move on. Okay, let's continue building that muscle memory of yours. You are going to do almost the exact same thing as you did with the sum, but this time with the cards. Because obviously, when you start the game, you can see your sum now, but you can't see your cards. That has to be fixed. So it's the same three-part challenge, starting in the HTML, where you are to give the cards paragraph an ID of card cell. Then in the JavaScript, you are to store the cards paragraph in a variable called card cell with camel case, and then finally render it out in this format right here. So go ahead and do this right now, and then I will show you how I will do it when you revert back to the screencast as well. Okay, let's do this. First, giving this an ID of card cell, then storing the card paragraph in a variable called also card cell. Let cards L in camel case this time, document.getElementById, passing in cards-L like that. Now I'm just going to jump straight to this line here and do cards_L.textContent equals constructing the entire content of the paragraph this time. So we're clearing out the text that's already there and replacing it with a new cards colon. This will be actually cleared out and replaced using JavaScript. And then plus the first card. And then I have to add a space between the first card and the second card. And then the second card like that. If I run this code, start the game, and there we go. We have both of the cards rendered out. Great job. Let's move on. So our game really starts taking shape now. We hit the start game button, then we get the message, the cards, and the sum. However, a critical part of blackjack is the ability to draw a new card from the deck. So we need to start building that feature, and we are going to first begin with creating the new card button that you can see on the slide here. So in this three-part challenge, you are going to first head into the HTML and create that new card button, and then make it run a new card function when it's clicked. And then in the JavaScript, you have to create that new card function. And for now, it should just log out drawing a new card from the deck. Then in the CSS, you need to make sure that when these two buttons are rendered out vertically like this, so above each other, you'll need to make sure that this small space between them is added because it won't be added by default. Now, if you enlarge in this browser, make it wider, they will render out beside each other. But you are not to worry about that layout. So make sure you keep this browser window a little bit narrow so that they are rendered out under each other. And then make sure that you get this little gap here. So this is again a very holistic challenge. You are to write JavaScript, HTML, and CSS just like it is out in the real world. So go ahead and give this your best shot right now. Okay, hopefully that went well. If not, no worries, let's do this together. In the HTML, we are starting with the button, open and closing tag, new card, like that. I'll just render it out. Ooh, there we got it actually. Got them beside each other. We want them vertically like this. So there we can already see that we are missing the gap that we wanted. But that's the CSS part of the challenge. Let's continue on with the HTML and get that wrapped up. We'll do on click, equals, and then run this new card function, which we haven't created yet, which we are going to create right now, down here. Function, new card, open and close parentheses, and then the curly brackets for the body of the function. Inside here, logging out this string we got provided in the comment, like that. I'll run this code, hit new card, and indeed we are logging it out. Now, final step is to add this gap right here. We need to head into the CSS, and there are multiple ways to do this. One way is to just say that we want any button to have a little bit of margin below them. So this is about 4 pixels. So we could do margin bottom 4 pixels. Like that. There we see that our button works. Alternatively, let's say that we, in some case, end up with a situation where something comes too close to the button on the top side of it. Well, maybe we need some margin on top of it as well. But if I now add margin bottom and margin top of 4 pixels here, margin top 4 pixels, what you'll see is that the gap here became twice as wide because it has the top margin that pushes it down, and also the start game button that uses its margin bottom to get the gap even larger. So what we then instead can do is take 2 pixels on each. Now we have something that looks very much like this. And we have created our buttons so that they always have some space below and above themselves. And I think that makes a lot of sense, as buttons usually want a little bit of space around them. With that, let's move on. Okay, let's make our new card function a bit more useful, because now it's just rendering out this string. What we wanted to do is to actually draw a new card and then add that new card to the sum, and then rerun the code that is inside of the start game function so that the sum is added to the page. And actually, later down the line, we also want to show the new card, of course, but as for now, we're just going to worry about the sum. So, this is a 3-part challenge where you are to first create a card variable, and we're still just working with hard-coded card variables. You're just going to code it to a number between 2 and 11. Then you are going to add this new card to the sum variable. And the sum variable is the one up here, of course, which currently is the first card plus the second card. And in this case, it'll be plus the third card as well. So you need to plus equal the sum variable. And then finally, you are going to just call the start game function. Because what does the start game function actually do? Well, first, it renders out the 2 cards. In our case now, we'll have added the third card, so this will still be wrong. But line 13 will render out actually the new sum, because at this point, sum will have changed, since we'll have modified it down here. And then it'll show the message based upon the new updated sum. So actually, it seems that we can use this start game function even after we've drawn a new card. And thus, we're going to rename it a bit later, but as for now, let's just keep it how it is, and your job is just to call the start game function here on line 33. So, go ahead and give this challenge your best shot, and then I will show you the solution as well afterwards. Okay, let's do this. So, we'll let card here. We'll set that to a random number between 2 and 11. I'll do 7. And then we're going to add the new card to the sum variable. If you remember how we add numbers to an existing variable, it's via the plus equal operator. So we'll do sum plus equal card. And then we'll call start game. So start game like that. Let's rerun the code. First, do start game. Okay, do you want to draw a new card? I happen to want to do that, so I'll hit new card. And boom, I drew the 7 card, which then made the sum reach 21, which then again made our dealer tell us that we got blackjack. So that is exactly what we want. Now, let's see what happens if we, instead of a 7, got an 8. If I now rerun the entire code, start game, and then hit new card, bam! Then we're out of the game since we have sum equals 22. And if we got a 6 instead, I'll rerun the code, start game, new card, then we still get the do you want to draw a new card text since we're still below 21. Now I can actually hit the new card yet again, and then we are out of the game. Now we're at 26. So this works for multiple cards. Of course, it's only the sum that's reflected right now, not the cards, so we'll have to fix that in a bit. But for now, let's just move on and first fix this little problem that the start game function name doesn't really make sense anymore, since we're calling start game here at a point where the game has already started, so semantically it doesn't really add up. So let's move on to the next cast. So the problem now is that the start game function is triggered both when we hit the start game button, which makes a lot of sense, but also when we click the new card button, because even though the new card button triggers the new card function, which is this one right here, that function itself calls start game as well. And while this makes sense because we want to run this code, the fact that start game still is called start game doesn't really make sense, because if another developer comes in here and looks at that code, they'll be like, why are we starting the game all over again when clicking a new card? That doesn't semantically add up. So what we want to do here is actually just change the name of the start game function, for example, to render game, because that's essentially what we're doing. We're rendering out the current state of the game. So we can do render game, just rename this one and this one to that. So far, so good. But then the problem becomes that we're actually calling start game here. And we could do render game like this, but actually I want to keep this start game function intact, because down the line there might be some other things we want to do in this game initialization function. So I want you now to create a function that uses the name start game and then just calls or invokes render game. That's all it should do, so that this start game button will work. Because now you can see it doesn't work when I click it. We're actually getting a reference error saying that start game is not defined, because we're trying to call a function that no longer exists. So go ahead and create the start game function here on line 12 and make it just call this render game function right here. Go ahead and do this right now. Okay, hopefully that went well. The way to do it is through function and then start game, open and close parentheses, open and close curly brackets, and inside here just call render game, like that. Let's rerun the project, hit start game, and yes, now it works again. Great job. Okay, so now we need to fix up the rendering of the cards. Because if I hit start game and I get the 2 cards out and then hit new card, indeed our sum increases, but our cards paragraph are displaying only 2 of the 3 cards we've pulled from the deck. Because we have a 10 and a 4 and a 6, whereas we're only showing the 10 and the 4 in the browser because that is hard-coded here to only do that. No matter how many cards we pull from the deck, this line 16 will always just render out the first card and the second card. So this line here in pseudocode says render out first card and second card. But what we instead need is something that says render out all the cards we have, regardless of how many cards. If we have 5 cards, it should render out 5 cards. If we have 2 cards, it should render out 2 cards. But that's not possible with the current implementation. And what we need is a central way of storing all of our cards. We need to store all of our cards in one variable, regardless of how many cards it is. And the way to do this is actually to use what's called an array, which is essentially a list of items. And I'm going to create an array here, and it's totally okay if you now feel confused. I just want to give you a little sneak peek at it before we take a deep dive and give you some practice on it. I'm going to do let cards equals, and then open and closed square brackets. That's the notation for creating arrays. And inside of these square brackets, I'm going to paste the first card, then a comma, and then the second card. So this is now a cards array that includes both cards, ordered by the first card first and the second card second. You can call this an ordered list of items. Now, we down at what's line 18 now, and replace the first card by referring to the array instead and doing open and close square bracket and 0. Don't worry about that, you'll understand that in a minute. Let's just now do the same things for the second card. And then we'll do cards, open and closed square brackets, and 1. So this is referring to this one right here, and 1 is referring to this item right here. And that is because arrays are so-called 0 indexed. They start at 0 and 1, and if we add a third card here, that would be index number 2. But we don't have a third card, so let's remove that. Now, even though you might feel a little bit confused now, let's just run the code hit the start game and see, yes, that it still works. So this way of doing it was the exact same as what we had previously when you just hard-coded in first card and second card like this. Now this opens the possibility later down the line to render out all of our cards in a dynamic way inside of the cards element, regardless of how many cards we have inside of our cards array. So that was a lot of information. Now we're going to take a step back, work with arrays, get your hands dirty. So don't worry if you didn't quite understand this, as you will surely do that after the next few lessons. Okay, so arrays are ordered lists of items. However, that's a little bit abstract. So let's instead look at a real-world product and see if we can recognize any components that most likely use arrays as a data structure. So here we have a LinkedIn profile. This is Justin. He's a previous Scrimba student. And looking at this, there's immediately multiple components that most likely use arrays to render stuff out. You can see here on the right-hand side, there are some promotions, actually 3 of them, and that's basically a list of items. And while their order might be a little bit random, they still have a specific order. Likewise with the people also viewed here. That's a list of 4 people. Let's also scroll a bit down. Here we can see even in the main section, there's this component that says featured. That is featured posts. And that's basically just a list of items. So LinkedIn probably uses an array to describe this data in JavaScript. So actually, let's just create that array. Do let featured posts like that, and then equals open and closed square brackets. The first one is actually Justin sharing the Netflix clone he built through a course here on Scrimba, and he actually deployed it as well. So he's going above and beyond. So check out my Netflix clone like that. The second one is actually a link Justin has shared to source code he's pushed to GitHub, which is also a great thing to do if you want to attract employers. So here's code for my project. I'm simplifying, of course, the data here because there are multiple parts of this. There's an image, there's text, there's comments, and so forth. But as for now, we're just simplifying it into strings. The third item here is actually Justin sharing the portfolio he has built through a Scrimba course as well. So I've relaunched my portfolio like that. There we have an array with 3 items. Now, this line is pretty long, so sometimes you'll see an array formatted like this, as it makes it easier to see that it is indeed 3 items. And a key thing to observe here is that we add commas after the items, but not after the final item. So only between items, basically. So going back to LinkedIn, there are tons of components here that's probably utilized as arrays. For example, the work experience, that's a list of previous jobs, or licenses and certifications, that's a list of licenses. You can see the front-end path right here. And skills and endorsements. So a ton of examples. And now what I want you to do is to create an array that lists your experience or education or licenses or skills or something similar. You are to choose what you want this array to contain. But try to think, how can you best describe your either experience, education, skills, or whatever in a way that would make your LinkedIn profile look tempting for recruiters? As that's a smart thing to think a little bit about already, even though you're very early in your coding journey. So go ahead and do that, and remember that the items should just be strings, just as I've done up here. Go ahead and do this right now. Okay, hopefully that went well. Now I'm going to do it as well. So I'll do let and then experience. That's what I want to create my array about, my work experience. And I'm currently the CEO at Scrimba. Before that, I was a front-end developer at Soneta. That's a Oslo-based company for sea freight analytics. And also, as you probably remember from our subway counter app, I worked as a people counter out in the cold for a company called Norstat. So that is my experience. Now, before you move on to the next cast, I want to highlight the importance of actually being able to describe your background and your skills in a good way on LinkedIn. Justin here, the person behind the LinkedIn profile we looked at, he actually lost his job in the petroleum industry due to the coronavirus pandemic, and less than 1 year later, he now works as a professional software developer. And as I said, he did that mostly through Scrimba, and was a super engaged student at our Discord channel. And what's so cool about how he did it is that he sent out over 100 job applications without getting much luck, but then went into optimizing his LinkedIn, and then suddenly he got 2 job offers. And the job he got actually came through a recruiter that found his LinkedIn profile as a result of keyword searches. Actually, he ended up tweaking his LinkedIn profile so that he attracted the right recruiter who got him an amazing job as a developer. So, I wanted to share this with you. And if you click on this image, you'll be taken to the page for the podcast interview we did with Justin, so that you can listen to his story if you want to. For example, when you're riding the bus or out walking or cleaning or whatever. I don't want you to interrupt the course and listen to this instead of coding. It's more important that you code. But you can keep it in mind for the next time that you have half an hour or something, because I think you'll learn a ton about Justin, who at the age of 33 did his career shift. So with that little plug out of the way, let's move on. An important thing to know about arrays is that they are so-called zero-indexed. And that means that you want to grab the first item of the array. You do it through using the 0 index, not the first index. And let me show you what that means in practice. Featured posts, that's our array. And I want to grab the first item, the check out my Netflix clone. I'll do that through open and close square brackets, and then passing in the number 0. If I now console log this, and we run the code, you can see, yes, that we are indeed logging out that string. So this isn't entirely intuitive, since we as humans normally start counting at 1, but in arrays, you start counting at 0. So if this is the 0th index, which index does this item have? Take a guess. Well, it has the index of 2, even though it is the 3rd item. I run the code, you can now see that passing in 2 logs out I've just relaunched my portfolio. So here is the 0 index, this is the first, and here is the 2nd. Now, with this in mind, I want you to practice this. So you are to take my experience array here and log out the following to the console, and in this order. So you are to start with the front-end developer in the Soneta, then the people counter, and then CEO at Scrimba. So first this one, then this one, and then the first one. So you have to write 3 console logs and place them in order here, starting from line 18, so that I'm sure that you actually understand the concept of arrays being 0 indexed. I'm going to comment out this one right here so it doesn't disturb you. Now go ahead and solve this challenge. Okay, hopefully that went well. Let's do this together. We're going to do console log. I want the front-end developer at Soneta. That is not the first, but the 2nd item. And in terms of indexes, it's the 0th and then the 1st index. So then I need to do experience 1. Okay, I'm going to copy this one, paste it in again. Now I'm going to log out the 3rd item, which is the 2nd index. So that is experience 2. And finally, I'm going to log out this item right here. That has the index of 0. If I run this code, you can see in the console that we are indeed logging out the items in this order. Now, before we move on, I'm going to confuse you a little bit, because let's actually delete all of this, remove the console, and just go back to this featured posts. If I now do featured posts dot length, and then console.log this out, which number do you think we'll see printed to the console? Take a guess. Well, the answer is 3. And that might be a little bit confusing because I've just taught you that arrays are 0 indexed. So the first is 0, the second is 1, the third is 2. So it would be natural to believe that the dot length property of this featured post is 2 because the final index is 2. But whereas indexes are 0 indexed, the length is not 0 indexed. We count the length of an array in just the same way you would count anything in life, which is starting at the number 1. So that also means that the length property of an array is always 1 larger than the final index. So this is one of those things that are a little bit unintuitive and confusing when learning JavaScript, and you probably will mix it up a couple of times. That's not a problem. Just trust me when I say that eventually this will become second nature for you. So let's move on. Okay, up until now, our arrays have either included only strings or only numbers. However, they're not limited to that. You can actually put any data type you want into an array, and you can mix as much as you want. So you can think of an array as kind of a composition of multiple data types and their values. So this is why arrays are what we call a composite data type. You can say it's composed by its items if you need it to make semantically sense. And you'll often hear this also referred to as complex data types. That is arrays and also, for example, objects, which you are going to learn about later. And they stand in contrast to the primitive data types you have worked with up until now. The three primitives you have learned are strings, numbers, and booleans, because they are more primitive than arrays. They are not composed of many other data types, which arrays often are. So one analogy you can use is that the primitive data types are the Lego blocks, whereas the array, the composite data types, is kind of like the full Lego model, for example, after you've built a little house with your Lego blocks. But anyway, you shouldn't worry too much about this if you find it a little bit abstract and complex. As a developer, you don't go around thinking about, oh, is this a primitive data type or a complex data type? It just becomes second nature and you don't even think about it. So you shouldn't be put off by this, even though it's a little bit theoretical. Instead, I think you should just practice. Now I want you to create an array that describes yourself and use all the three primitive data types that you've learned so far. So it should contain your name, which is a string, your age, which is a number, and whether or not you like pizza, which should be a boolean. So go ahead and do this right now. Okay, hopefully that went well. Now let's do it together. I'm going to create an array called pair. And my name is Per Harold Borgen. I am 35 years old, and I do happen to like pizza. And I especially like pizza with pineapple. It's the best. Though I know that a lot of you don't agree with me, so let's not get into a discussion about that. Let's just move on with the course. One of the most common operations you'll perform on arrays is adding items to the end of it. That's, for example, what you want to do in our blackjack game, where you start with 2 cards and then you want to draw a new card. That'll naturally then be put at the end of the array, for example, 6. However, the way to do that is not through actually changing it directly, which I did now. You use a method, which is called push, which allows you to, well, push things into the array. So you do cards, dot, push, and then open and close parentheses. And inside of these parentheses, you place whatever you want to push. So for example, 6. If we now console log the cards underneath our push operation, you can see we have added 6 to the array. So this here is actually called a method, which is just a fancy way of saying a function on an object. And you haven't really learned about objects yet, so don't worry about if you think this sounds a little bit abstract. But this operation here is pretty similar as the console.log, then passing in, for example, hello. Don't you think? We have the first object, cards or console. Then we have the methods, which is either log or push. And then we have whatever we pass into these methods when we call them. So this here, cards push, is conceptually very similar to what you've been doing all along. Let's now make sure that you build muscle memory on this by solving a challenge. So I want you to imagine that you are building a chat application. For example, the one I showed you here on LinkedIn. And the data structure we'll use is, of course, arrays, and we'll pretend that each of these messages is an item in the array. So when someone types in a new message and sends it, well, you want to push that new message to the array. So here you are to push the new message variable, that's this one down here, into the messages array. That's this one here. And then you are to log out the array to just verify that you actually succeeded in pushing the item. Go ahead and do that right now, and then I will show you the solution afterwards as well. Okay, hopefully that went well. Now, let's do this. We'll do messages dot push, and inside of the parentheses, we'll pass in new message like that, referring to the variable and not the hard-coded value, which we did up here when we passed in 6. So a little bit different, but still the same concept. Now, let's console.log messages, and then run this code. If we bring up the console, we have pushed the new message to the array because we're logging out the array with same here at the end. Now, a little mini challenge before you leave. Let's say that you wanted to regret sending this message, same here, and you wanted to remove it from the messages array. How can you do that? You haven't learned this yet, but this is a golden opportunity for you to Google it out and try to figure out how can you remove the last item in an array. So just see if you can find the answer on Google and then try to remove the last item of the messages array here on line 18. Go ahead and do that right now. Okay, maybe that worked, maybe not. If not, no worries at all. This is just a bonus. What you do is do messages dot pop and then open and close parentheses. Now, if we log the messages again and then run the code, open up the console, you can see we are logging 2 versions of this array. One from line 15, where the same here string is included as the last item, and once again from line 19, where the array is back to how it originally was, like this. So pop is kind of the opposite of push and not as commonly used, but I just wanted to give you a sneak peek at it, as you might come across it here and there in your development journey. With that, let's move on. Okay, now it's time for some repetition. You are going to do the exact same thing as I did before we had our little arrays deep dive. So you're first going to create a new array, cards, that contain the first card and the second card. And then in the render game, you are going to change line 18 so that it refers to the cards array when rendering them out. So not referring to first card and second card this way, but doing it via our freshly created cards array. So go ahead and do this right now. Okay, let's do this together. First, we'll do let cards equals open and closed square brackets, and then we'll set the first card as the first item in the array and the second card as the second item. And as you hopefully remember, we can now refer to these values by doing cards 0 and cards 1, like that. We'll run the code, hit start game, and yes, indeed, it works. Great job, let's move on. Now that we have the first card and the second card in the cards array, we also have to, of course, add the new card to the cards array. So, quick little challenge. After this card has been created and it has been added to the sum, we also need to push the card to the cards array. So, go ahead and do this right now. Alright, the way to do this is by writing cards dot push open and close parentheses, and then pass in the newly created card, like that. And in order to verify that this actually works, we can, on the next line, console log out the cards array, like that. Let's run this again, start game, hit new card, and there we can see in the console, now the cards array has been logged out with all the 3 cards, 10, 4, and 6. So we still aren't rendering out the third card though. And to achieve that, you have to learn how to count in JavaScript. Or strictly speaking, you have to learn how to write for loops. So over the next few casts, we are going to take a deep dive into for loops, and then later return back to the blackjack game so that we can fix it up. Let's move on. Okay, so now you're going to learn how to count with JavaScript. That might sound really silly. I mean, counting is so easy. If you ask a human to count, for example, if you say, pair, count to 10, I would go, yeah, sure, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However, JavaScript is like that annoying person who then replies and said, well, where exactly do you want me to start counting? And by counting to 10, do you mean including 10, or should I stop before 10? And also, should I count every single number, or do you want me to, for example, only count the odd numbers or the even numbers or whatever? So JavaScript is really like that annoying person that takes everything you say 100% literal. So when you ask JavaScript to count, you have to be super specific. We need to specify where we start counting, where the finish line is, and what the step size is. Here, I've already written the code for you, so let's just dissect it. We start with the for keyword. That's because this is a so-called for loop. But don't worry about that. Let's now look at the things that are inside of the parentheses here. Here, you can see our starting condition. Let count equals 1. So we're going to start our count at 1. Then we have a semicolon. And then we specify our finish condition, where it says count is less than 11. So we want count to always be less than 11. So maximum 10, in other words. We're never going to count over this number. And finally, the step size is that for each counting, you're going to increment with 1. So count plus equals 1. Now, these three conditions together describe to JavaScript how many times we want to run the code inside of the curly brackets and what the value of count will be at every single iteration. So here we are going to run this code 10 times, and the variable count will change its value in every single iteration, starting at 1 and going up to 10, jumping one number at a time. So we will count to 10. Let's run this code. And there you can see in the console, we get the numbers from 1 and up to 10. If we now changed this here to 2, what do you think will happen? Well, then we get 1, 3, 5, 7, 9. Because we still start at 1, we're going to end before 11, so maximum 10, and we're going to jump with 2. So in the first iteration, count equals to 1. It's what we said we wanted to start with. But then in the second iteration, we've told JavaScript that we want to increase by 2 every single time. So then it's 3, and then it's 5, and then it's 7, and then it's 9. And then at the last iteration, it's like, okay, now I'm going to be 11. But that doesn't work. That violates our finish condition here. So JavaScript stops the loop before that happens and then continues on with whatever it has to do underneath the loop. So let's take this back to 1. Can you modify this one so that it counts from 1 to 20? How would you do that? Hopefully, you identified that what you want to change is the finish condition and set that to less than 21. When you run this, you can see in the console that we're logging out 1 to 20. Now, how would we change this if we want to count from 10 to 20? Go ahead and try that right now. Okay, hopefully you figured out that it is the starting condition you want to modify. You want to write 10 here so that it starts at 10, ends before 21, and counts 1 at a time. If we run the code, you can see we get from 10 to 20 logged out to the console. So hopefully you've gained a little bit of intuition on this now. Let's move on to the next cast. Okay, let's first walk through how to create a loop from scratch. And then I want you to create your own loop, or at least try, according to the specifications here on line 3 and 4. But to begin with, we'll create a loop that counts from 0 to 5. So to do that, we'll do for, open and close parentheses, and then inside of the parentheses, we have to define our starting point, our finish line, and how big our steps will be. This is done through a counter variable, so we could do let count equals 0, and then semicolon to end the starting statement, because 0 is where we want to start. However, whereas count is a very semantically good word for this variable, a common convention in JavaScript is to use the letter I instead. We could have named it whatever we want, and you can use count if you think that's easier, but I'm going to use I from now on. Then there's the finish line, which we also need to define, and we want to count to 5, so I should be less than 6. And then semicolon again. So this defines that I should always be less than 6. And obviously then the last point where it will stop when counting upwards is 5. And then finally we have to define how big our steps should be. Now I'm going to do I plus equals 1. Here we don't have to use a semicolon to end because this is the last condition. Actually, I can space it out a little bit. We follow the same structure for all of our conditions. And then the open and closed square brackets for the body of our for loop. Then inside of here, we'll do console.log I from the code. And we can see 0, 1, 2, 3, 4, 5. Good. Okay, now that you've seen this, I want you to try to create a for loop that counts from 10 up to 100 in steps of 10. So it should count 10, 20, 30, 40, 50, and so on, including 100. And I want you to use console log, as I am doing here, to log out the count at each step of the iteration. So go ahead and do this right now. Okay, hopefully that went well. If not, no worries. Let's do this together. We'll do for let, and here you might wonder if, well, we've already used the I variable. Can we reuse it down here? And the answer is yes. I is only defined inside of the curly brackets of the for loop when you do it like this. So outside of it, for example, down here at line 8, JavaScript won't remember this I variable. So whatever you've configured it to mean up here inside of the curly brackets doesn't affect whatever you set I to down here. So we can do let I again equals 10. That's where we're going to start. I should be this time less than not 100, because then it'll stop at 99. It needs to be less than 101. And finally, I should not be plus equals 1, but it should be plus equals 10, because at each step in the iteration, you want to increase I with 10. Console log I. I'm going to comment this one out, run the code, and there we see 10, 20, 30, 40, 50, and so on, all the way up to 100. So, great job. Okay, now you're going to experience how powerful for loops are when combining them with arrays. Because let's say that we are building a chat application, like the one that LinkedIn has, which I showed you earlier. And these messages might just well be items in arrays. Let's just pretend that each of these messages are exactly that, and ignore all the metadata around the messages, like the time and the profile picture and name and stuff like that, and just pretend that we have the data structure which contains a bunch of messages inside of an array. Basically, just what we have here, the exact same array we've worked with earlier as well. Now, pretend that this is a console-based array, so everything basically need to do is log out these messages to the console. But in order to do that, we can't just console log out messages, because then we'll just get a long array, and that's not what we want. We want each of the messages on its own line and not with the square brackets and stuff like that around. So the hard way to do this is by doing like this. Messages 1, messages 2, messages 3. Like to take the index from 0 to 3 and log all of them out. There we go. Now we have what looks like a chat in the console. But this is a really bad way of doing it. We are repeating ourselves again and again, and that's a general anti-pattern. There's something called DRY for don't repeat yourself. So don't write more code than you need to, and especially not if you're just repeating the same code. And also, this doesn't scale, because if I add now at the end of the array and run the code, I'm not logging out the last one. I have to manually update my code. So what we instead want to do is combine this array with a for loop. Now let's comment out this and write for let I equals 0, semicolon. And then we want I to stop before it reaches 5. And then we want I to increment by 1 at every single iteration. Now inside of this for loop, we log the value of I. See in the console that we get from 0 to 4. And that actually resembles quite a lot what we did here. However, we've even added the index of the latest item as well. So how about we, instead of just logging out I, simply do messages, open square brackets, close square brackets, use the I as the index, and then run the code, and boom, there we go. We have all of the items logged out in order, one after another. Brilliant. However, there's still a little problem here, that if I add yet another message here, maybe an emoji, and I run the code, the emoji isn't logged to the console. Then I have to change this to 6 again, so it's still not fully dynamic. However, I have a trick, because how can I get a hold of the number 6 in a dynamic way? Well, you might remember that arrays has a property which is called length, and that will refer to the actual length of the array. If we use that, we can be sure that our loop counts up to the final index, all the way up to the end of the array. If we now run the code, yes, there we have all of our messages, regardless of how long the messages array is. So this was a lot of typing from my end though. So let's move on to a challenge so that you get to practice this as well. Okay, so now let's return back to the example of having cards in an array, like we have in our blackjack game. So here I've created an array that has 3 cards of the values 7, 3, and 9. And I want you to create a for loop that logs out all of these cards to the console. However, not by hard coding where the loop should stop counting, but using the cards.length property. So go ahead and do this right now, and then I will of course show you the solution as well afterwards. Okay, hopefully this went well. Let's do it. We'll do for, open and close parentheses, and then let I equal 0, because we're going to start at the 0th index. I should be less than cards dot, and I should be increased with 1 at every step in the iteration. Now, here, for this last condition, I actually want to show you another trick, because what you can do here is actually do I++. That'll do the exact same thing as this. It's just syntactical sugar that JavaScript provides us with to make our code a little bit neater. So I++ increments I with 1. So now we can do console log cards, then passing in the I, run the code, and there we can see 7, 3, and 9 printed to the console. Great job. Okay, this is so cool, because now you are going to combine what you've learned about arrays and for loops with what you know about manipulating the DOM. So we're going to pull the strings together and have you render out this sentence inside of this greeting L. So you can see we have in our HTML just an empty paragraph which has the ID of greeting L. We have fetched that element from the HTML and stored it in this greeting L variable. And your job is to render the sentence, that is the array here. So you are to render all of these items inside of the array in the greeting L paragraph. And the way to do that is to use a for loop to loop through it and render each of them into the greeting L using .text content. So a lot of stuff you have to keep track of here, but give it your best shot, and then I of course will show you the solution when you return back to this screencast. Okay, hopefully that went well. Now let's do this. Before, let I equals 0, because we want to start at the 0th index in our array. We'll do I is less than sentence.length. And then we do I++, because we want to increment 1 time. Here, we need to grab a hold of the greeting L, and then do text content. And here, you might have been tempted to do equal sentence, open and close square brackets, and passing in the index. That will just end up with rendering pair, because first it renders hello, and then it clears out all of the text content and renders the second word, but then for every single time in this loop, it clears out all the text content, and we end up with just the result after the last iteration. And that was the last word in the array. So what we have to do, we have to keep the previous content intact inside of the paragraph. And as you might remember, we do that with plus equals. So running the code again, yes, now it works. Now though, I have a bonus challenge for you, which is the following. How do you keep the spaces between the words if I remove these spaces from the array? That is, if I do like this, like this, like this, and like this, and we render it out, you can say, we have no more spaces. It looks like one long weird word. How can we on this line 7, modify it so that we get spaces between the words. Go ahead and try that. Okay, what we will do is we'll simply, at the end here, add a plus and concatenate our given item in the array with a space. So now we add a space after each of the words. If we render this, you can see, yes, we get now the sentence exactly how we want it. Great job, let's move on. Okay, back at our blackjack game, it's time for you to create a for loop that renders out all the cards in the cards array instead of just the 2 first ones, which we are doing up here. So you are going to start your for loop down here at line 19. And I'm going to help you out a little bit because we are going to keep this first setting of the text content here so that we have the default text inside of the paragraph. And then you are going to render out the cards after this text inside of the paragraph. Go ahead and create that for loop so that our blackjack game supports any number of cards inside of the cards array and will render all of them out regardless of how many it is. So give it your best shot and return back to me when you want to see my solution. Okay, hopefully that went well. If not, no worries, we'll do it together. We'll start with for, and then open and close parentheses, of course. Inside of the parentheses, we need to define that we want to start our incrementer at 0, and we want to stop it before it reaches the length of the cards array. How do we do that? Well, by I is less than cards.length. And then a semicolon, and we want to increment I at every iteration. The body of the for loop with curly brackets. Here, we are going to plus equal onto this paragraph. So we'll do cards L.text content plus equals. Let's start by just adding the cards and then passing in the current value of I, our iterator, which will start at 0 and to begin with end before 2. So it'll be 0, 1, and then run the code, start game, and yes, it works. However, it looks like it says 104 here because we haven't added a space between our numbers. So the way to do that is simply by concatenating a space after pin card. Now if we run it, start game, yes, we've got it. And if we hit new card, now we can see both the sum and the cards are now correct according to the state of our game. Great job, let's move on. Okay, so our blackjack game is actually turning out pretty good now. You can start the game, you can hit a new card, 20, I can even hit yet another card, boom, I'm out of the game. It's almost fun to play, though you'll get pretty tired of it as you play it multiple times since you every single time get the exact same cards. So not exactly an exciting blackjack game. And of course that is because we have hard-coded the variables for our first card and second card here, and also hard-coded the value for our third and fourth and every preceding card here on line 40. So we'll always get 10, 4, 6, 6, 6, 6, 6, 6, and so forth. So what we need to do is instead create a function, getRandomCard, that returns a random number. So that we, instead of hard-coding the number 10 up here on line 1, we can do getRandomCard and call that function. This function will then return a random card that the first card variable will be set to. And we can do the same with the second card, and also down here in the new card function, we can do getRandomCard there as well. This way, we'd get a functional blackjack game. However, there's a few things you haven't learned yet, which you need to learn in order to create this getRandomCard function. So let's rewind a little bit here, get back to the hard-coded numbers, and over the next few casts, you're going to learn how to return values in functions and also how to generate random numbers inside of a function. So let's go ahead and do exactly that. Okay, let's return back to our racing game example in order to learn about returning values in functions. So here we have two players who've raced through the game, and player 1 got the time 102 and player 2 got the time 107. And our job is to create a function that returns the fastest race time. So in order to do that, we first have to do function. And I'm going to call this getFastestRaceTime. Quite a long word, but at least it's descriptive. And inside of the body of the function, we have to first check which of these times were fastest. So we'll do an if statement and say, if player 1 time is less than player 2 time, well then we are going to return player 1 time. Because if it's less than player 2, then it's the fastest race time, and we are going to return it. Now, this return keyword here might now seem a bit weird, and you probably don't understand yet what it means, but don't worry about that right now. It'll be clearer as we move on. And then we're going to do else if. The next condition is if player 2 was faster than player 1, that is, player 2 time is less than player 1 time. If so, we are going to return player 2 time, like that. Then an else if actually these two are equal, so none of these expressions evaluate to true. Well, then the fastest time is any player's time because they have the exact same time. Could either return player 1 time or player 2 time, it doesn't matter. I'm just going to return player 1 time. Okay, now what we can do is we can do let fastest race. I'm going to call this variable that, and now I'm going to define that, declare that variable as the result of invoking this function. So I'm going to do get fastest race time, like that. Now, the value of fastest race time will be whatever this function has returned. And if we console log fastest race time, we can see we get 102. That's correct, because this function compared player 1 and player 2 and rightfully recognized that player 1 was faster than player 2 and thus returned player 1 time. What you might think now is, well, we're just console logging out the value here. What's the point? Why couldn't we just, instead of these returns, just do console.log and do that directly inside of the function? Do that first and run it. You can see, yes, we are now indeed running this line 6 here. We're console logging out the value. But if we down here try to see what is the value of fastest race at this point and run the code, you can see that we're getting 102 first from this line, but then we're getting undefined from line 16 because now the fastest race variable simply isn't defined because this function didn't return anything. And it's actually quite valuable to have stored the fastest race time inside of this value as opposed to just having console logged it out up here. Because now we can use this variable for something else. So let's do it like this and return instead and move over and remove the parentheses as well. We're wondering how I got the cursor to be on multiple lines at the same time. It's a trick where you first select a word and then do Command D. Or if you're not on a Mac, Control+D. Select the word, Command D 1, 2 times, and now I've selected all of the return keywords so that I can delete them or retype them. That was just a quick little tip. Now it's time for a challenge. So you are going to write a function that returns the total race time. Then you are going to call or invoke the function and then store the returned value in a new variable. You have to decide for yourself what you want to call that variable and what you're going to call this function. Then finally, you are going to log your variable out just to check that everything has worked. So go ahead and do this right now. Okay, hopefully this went well. Let's do this. We'll do function get total race time. And the way to do that is simply to return player 1 time plus player 2 time. Then we can create a new variable called let total time equals get total race time. And now we can console log total time, something like that, running the code, and indeed we get 209 in the console, which sounds just about right. So great job, let's move on. Okay, it's time to take what you've learned about returning values in functions and implement that technique into our app. This is a 3-part challenge. First, you're going to create a function, getRandomCard, that always returns the number 5. And then you're going to use getRandomCard to set the values of the first card and the second card. and then use it to set the value of the card variable down here in the new card function as well. So you are going to write your function getRandomCard here, starting on line 14. And now you might think, well, that doesn't make sense because we have previously learned that if you define a variable down here on line 14, we can't use it up on line 2 and 3. That's at least how it is with variables you define using the let keyword. And that is exactly right. But when you create functions in the way we do, there's an exception. So I want you to just try this and see if it works, and then I'm going to explain afterwards why it works. Go ahead and give this your best shot, and then I will show you the solution as well afterwards. Okay, hopefully that went well. Now let's do this. We'll do function getRandomCard like that. Then inside of the body of the function, we'll simply return 5. We need to use this up here at line 2, getRandomCard, and on line 3, getRandomCard. So what's happening here is that we're calling this function. It will return 5, and thus second card and first card will be initialized with the value 5. As will our card down here. If we do getRandomCard and call it, these two really important, otherwise it won't work. But with them, card will now have the value 5. So let's run our blackjack game. Start the game. Ooh, we got 2 5s. Ah, yet another 5. What's the chance? Obviously, it is 100% at the moment, but that doesn't matter because we now have the setup for inside of this function, writing the logic for getting an actual random card back. So that's great. Finally, I promised to talk a little bit about the fact that we're creating the function down here on line 14 and then using it up on line 2. That seems to go against what we learned about variables early on. However, when you write functions like this, which is called function declarations, the function gets so-called hoisted to the top, meaning that it's accessible even at line 1, regardless of how far down you define the function. We could have written this function on line 10,000. It would still be accessible on line 1. Now, there are other ways of creating functions that don't give the function this extra benefit, but as for now, we're only going to write functions in this way, so don't worry about that. Because now you have another thing to worry about, and that is, how do we actually modify this getRandom function so that it actually returns a random card? So from the next lesson on, we are going to dive into exactly how to do that. I'll see you there. So I remember when I was learning this slightly clunky way of generating random numbers in JavaScript and thinking, well, why do I really need to generate random numbers? Is that really such a common thing to do for developers? And actually, it is. Of course, there's our use case where we're building a card game. Obviously, we need to have some kind of randomness in which card you get. Otherwise, it would be meaningless. But also, imagine all games that use dices. A dice is basically a physical randomness function that gives you a random number between 1 and 6. But randomness isn't only important in these kind of casino-ish games. I would say in all computer games, randomness plays some kind of role. For example, in this popular iPhone game Cross a Road, where you are to cross a road as a duck without getting hit by a car. Surely there's some randomness underneath here, which decides which cars appear on the road and so when they appear. But it doesn't stop there with games. Actually, in cybersecurity, random numbers is a key component in order to authenticate yourself and generate keys, as within cryptocurrencies. So for example, Bitcoin uses random numbers as well. So random numbers plays a role in the crypto economy as well. And most importantly, we used random numbers in order to generate the suggested tweet text in our JavaScriptmas advent calendar. So, as you can understand, random numbers are everywhere, and you need to learn the most basic way of generating that in JavaScript. And that is through something that we call the math object. That's something that's already provided to you in JavaScript, or by the browser to be specific, and you can type math wherever you want with a capital M, and then do .random, and then open and close parentheses so that you call this function or method. And don't worry if you don't quite understand what's going on under the hood here. You're not meant to do that right now. All you're meant to know is that that will return a number to you, which I've now stored in a variable called random number, and then I'm logging out this random number. What I want you to do now is pause this screencast and run this code a few times so that you get to see a few of the values that our random number variable can take, and then try to, as succinctly and specifically as possible, write your answer at what you think math.random does. So what does it return? Try to formulate that and write it down, and then return back to the screencast when you think you have the answer. So the way I would write this is that it generates a random number between 0 and 1, and in parentheses, not inclusive of 1. So it generates a random number, including 0 and 1, but not including 1. So from 0.000000 to 0.9999999, and a bunch of 9s after that. So if we were to visualize this slightly, say that math.random gives you a number from 0.000 and a bunch of zeros after that. I just couldn't bother writing all of them, to 0.9999999, basically a bunch of 9s as well. That is the range you are given when you give JavaScript this command. So if we run this, you can see we get 0.68 and a bunch of numbers, 0.95 and a bunch of numbers, 0.88, 0.001. Yeah, as you can see, we've already been almost from very close to 0 to very close to 1. Now, before we go, there's one thing I need to point out, which is that the randomness here, while it looks completely random for us humans, it's not truly random. There is some deterministic variables going on under the hood here. And it's actually a really hard problem in computer science to generate truly random numbers. But for our use cases, we're not going to worry about that. As far as we care, these numbers that we generate with math.random are more than random enough for our use case. This is not a PhD in cybersecurity, but rather getting you started with web development. So with that, let's move on. Okay, so now we know how to create a random number between 0 and up to, but not including 1. However, it's not entirely clear how we utilize math.random in order to create something useful, like for example a dice function. So let's take this one step at a time towards creating such a function. And the first step we're going to take is simply by multiplying math.random with 6. Now I want you to do the same thing that you did previously, which is to pause the screencast, run this code a few times and see what we log to the console, and then answer the following question. In which range will our random number be now? So from which number to which other number? It used to be from 0 to 0.99999. Now it's something else, and you have to figure that out. So go ahead and do that right now. Okay, the answer is that it still starts at 0, but now goes all the way up to 5.99999 and a bunch of 9s. I'm not going to type all of them. So if math.random gave us a number from 0 to 0.999, math.random times 6 will give us a number from 0, because 0 times 6 is still 0, to 5.999. Because 0 point a bunch of 9s times 6 is not entirely 6, but it's almost 6. So it's 5 point a bunch of 9s. So now we have kind of expanded our range, roughly speaking, from being between 0 and 1 to being between 0 and 6. We did that by multiplying it with 6. Let's move on to the next step. Okay, so now we need to learn another method on the math object, and that is math.floor. What floor does is it takes some input, a number, and then does something with that number, and returns it so that you can store that in a new variable. For example, like floored number right here. That is the floored version of this number. So I want you to pause the screencast, run this code a few times, and answer the question, what does math.floor do to positive numbers? And the reason I'm saying positive numbers is I don't want you to add negative numbers in here, because the mental model is slightly easier if you only think about positive numbers, and it's a bit easier to write a concise answer to it, in my opinion. And finally, I've never used math.floor on negative numbers anyway. It's usually used on positive numbers. So try this. Feel free to add a few different numbers in here and run the code. And once you're ready, just type out your personal explanation of what you think math.floor does. Go ahead and do this right now. Now, the way I think of MathFloor is that it simply removes the decimals. Because if we run this, you can see it returns 3. If we have 12.4, 12. Even 12.999999, still 12. Okay, so great job. With that knowledge in mind, let's move on to the next lesson. Okay, so just as a quick recap, math.random gave us a number between 0 and almost 1, and mathrandom times 6 then gave us a number between 0 and almost 6. And now we are going to combine this with math.floor, which you learned in the previous lesson. So I'm going to add it here. I'm going to write math.floor and then wrap our entire previous expression inside the parentheses of mathFloor. Now, what I want you to do is run this code a few times and then write down possible values that random number now can hold. So there's a limited number of them, and your job is to figure out exactly which ones. So go ahead and do this right now. Okay, hopefully that went well. Now let's run this together. You can see we got 4, 4, 0, 1, 4, 0, 2, 5. Okay. So it seems we are getting the numbers between 0 and 5. That actually makes a lot of sense, because if we take this range here between 0 and almost 6 and shove it into the math.floor function, then it will basically remove all of the decimals. And if we remove the decimals from this entire range, which numbers are we then left with? That's just the whole numbers from 0 all the way up to 5. So the right answer was 0, 1, 2, 3, 4, 5, like that. Okay, hopefully you're still hanging on. Let's move on to the final step of our dice function. Okay, now we are going to complete our dice feature, because we know that with this expression, we currently get a whole number from 0 up to 5. So the question then remains, how do we turn this range into rather a range between 1 and 6, which is essentially the same as a dice. And I want you to try this for yourself. Try to modify the expression so that we get a range from 1 to 6 instead of 0 to 5. Go ahead and give that a shot right now. Okay, hopefully that went well. To understand what we need to do, we can compare each of the numbers here. You can see that the first number here is 1 and the first number there is 0. And how do we go from 0 to 1? Well, we add 1. And the same goes for all of the numbers here. How do we go from 1 to 2? Well, we add 1. And from 5 to 6, we add 1. So basically, what we can do is just do plus 1 at the very end. Then if we run the code, you see we get 2, we get 6, 3, 5, 6, 2, 1. Yes, we indeed get the entire range of a dice. So, really good job reaching this far. Now I only have one last challenge for you, and that is to create a function called roll dice that returns a random number between 1 and 6. So basically, you're going to take what we've done here and wrap it into a function and then return the result. Go ahead and do that. Okay, to do this, I'll do function roll dice, open and close parentheses, open and close brackets, and inside of here, I'm just going to copy this line, paste it in, and then return random number, like that. Now I have to remove it from up here, because out here on line 2, random number isn't even defined, so we can't log it out. Random number is now only defined inside of the roll dice function, and the value of it gets returned. So if we console.log, and inside of the parentheses we call the roll dice function like that, should get, yes, a random number between 1 and 6. Really good job reaching this far. This was complicated stuff, so if you feel a little bit shaky with this, that's totally okay. You can go back and rewatch it and retry all of the challenges if you want to. And then when you feel ready, we'll move on and use this knowledge to make our blackjack game much better. Okay, we're back at our blackjack game, and we are going to fix up this getRandomCard function. But we'll do it step by step. So To begin with, I want you to make it return a random number between 1 and 13. So here you can pretend that we are working with the regular values that a deck of cards usually has. So with the ace being the 1, the numbers from 2 to 10 of course being their respective numbers, and then the jack being 11, queen being 12, and king being 13. So from 1 to 13, like this. Go ahead and give this your best shot, and then of course I will show you how to do it afterwards as well. Okay, now let's do this. We know that if we do math.random, we are going to generate a number between 0.000 and a bunch of decimals after that, up until 0.999 and a bunch of 9s after that as well. So the first thing we need to do in order to get this range to look more like this one is to multiply this entire thing with 13. 0.000 times 13 is still 0.000 is still 0, and 0.999 times 13 is actually just 12.999, or we have a bunch of 9s after that as well, so we're getting to something remotely similar. It's just a matter of how many 9s we have after the dot. But this is roughly the range we're working with this expression right here. So we want to remove the decimals. And how do we do that? Well, if you remember from previously, we can use the math.floor function and wrap the entire thing inside of the parentheses of math.floor. So now we take this expression here, this one, and we then floor it, which gives you like that and like that. So 0 to 12, that's what we're returning here. Now the question remains, how do we go from 0 to 12 to 1 to 13? Well, that's only a matter of adding a 1 to any given number. Just do like that. That should return a number between 1 and 13. Let's try to start this game and pull a bunch of cards to see if we actually get the entire range. 7, 4, looking good so far. 10, okay. 13, yes. 5, a bunch of other numbers. Getting way too many numbers here. Let's get that 1. Yes, there we got it. A 1. So we have the entire range from 13 to 1 and just about everything in between. This was not a normal blackjack round, but at least proved the point that this generates a random number between 1 and 13. So, great job reaching this far, but of course we have to modify it because in blackjack we're not following the usual value sequence for cards. So we need to modify our function a little bit, but we'll do that in the next cast. Now we need to change our getRandomCard function, because in blackjack, the jack, queen, and king are all worth 10, and the ace is worth 11. Or, strictly speaking, the ace can be worth both 1 and 11. You get to choose as a player what suits you best is the value you use. However, for the sake of simplicity, we are just going to treat the ace as 11 in our case, as having a dual value for this card would add a lot of complexity to our game, and it's not something I want to focus on. It's rather something you can, for example, do as a stretch goal later if you want to modify the game at the end of this course. So for now, we're going to treat our ace as 11. So this means we need to modify our getRandomCard function. If the number it returns is 1, then we should change it to 11. And likewise, if the number it returns is either 11, 12, or 13, we should rather return 10. So go ahead and modify this function so that these exceptions are followed. You're going to have to define a variable that this random number is stored in, and also have some kind of conditional that checks for these conditions and returns the appropriate value. So go ahead and give this a shot, and then I will of course show you the solution afterwards as well. Okay, hopefully that went well. If not, no worries, we'll do it together. First, I'm going to, instead of returning this directly, turn it into our random number. Like that. Then we need to write our conditional to account for these special cases. I'm going to start from the very top and check if random number is more than 10, meaning that card is either the jack, queen, or the king. So if random number is more than 10, what are we going to return then? Well, then we are going to return 10, because that is the value of the jack, queen, and king. And I'm going to do else if, and now I'm going to count for the ace itself, and for that I'm going to use the triple equals. So I'll do random number triple equals 1. and I'm going to return 11. And then in all other cases, you can just do else like that. In all other cases, it must mean that we have drawn either a 2, 3, 4, 5, 6, 7, 8, 9, or 10. And if so, we're just going to return that value. So then we're just going to return the random number directly, like that. Let's run the code. Hit start game. Okay, 5, 5. I'm going to just hit a bunch of cards to see that we get the entire range. And indeed, it seems that we does. We have a 2 here, we have an 11 here, and have almost every single word in between. I'm 100% sure that if we continue hitting the new card, in the long run, we'll just get random numbers across our entire defined range. So, great job. We're almost reaching the end of our blackjack game. You should really be proud of yourselves for reaching this far. This is starting to get advanced. There's even more to learn, so let's just keep up the pace and move on. Okay, there's one really weird thing with our blackjack game, and that's easily exposed if we console log out the cards here at line 12, and then refresh the page. There you can see I got 2 and 7, and the reason that's weird is because I haven't even clicked the start game button. I kind of just entered the casino, and the casino has already decided what cards I am to be dealt. That's fishy. We don't want that. I want the cards to be generated as I click on the start game button. So the first card and the second card should be generated inside of the start game function. And thus, the cards and the sum also needs to be reassigned inside of the start game function. And also, the is alive shouldn't be set to true by default. Before I've even clicked the start game button, I'm not alive. I'm not even playing the game. I'm going to use that as an example. Set it to false first. And then inside of the start game function, I'm going to do is alive equals true. So now we have the correct starting state before I've entered the game up here on line 6, and the correct value once I've started the game down on line 26. So what I want you to do is make it so that the same thing happens with cards array, because it should not be set here, and the first and second card shouldn't even be defined up here, and the sum should be 0 by default. So this is how the state of the game is before I've started playing the game. Now, what you need to do down here at line 23 and 24 is generate the 2 random numbers, and then reassign the cards and the sum variables so that the game can start. So, you might find this a bit tricky, but do your best. There's no shame in trying and failing, because I will of course also show you how to do it when you return back to this cast. Good luck. Okay, let's do this. We'll start by defining first card and second card, and they should be defined by running the getRandomCard function. That'll give them the getRandomCard function. Second card equals random card as well. Now we can set the cards array to first card and second card, and the sum to first card plus second card, like that. And also, actually, get this console log back in again and rerun the browser. You can see now it's empty. The casino hasn't decided which cards I am to get. Very good. So hit start game, and there I got my blackjack. Oh my god, that's amazing. And with that, I have nothing more to say. I'll see you in the next cast. The next thing I want to fix is our new card button, because it's kind of broken. Let's see why. If I now start the game and I get 2 cards and I draw a third card and a fourth card and I'm out of the game. At this point, I shouldn't be able to draw more cards, but actually I am. I can hit it and I got another 10, so I'm at 34. Shouldn't be possible to get to that number in blackjack. So we need to stop it when the game is over, and also if we refresh the browser, I shouldn't be able to start with just 1 card either, but I actually can. So there's 2 conditions we need to check. Both if I'm still in the game, basically if the is alive is true, and also I can't have blackjack either. Now this requires us to learn something called logical operators, which lets you combine multiple conditions inside of an if statement, so that a piece of code should only be run if multiple conditions are satisfied. So let's take a little detour and learn about logical operators in the next casts. Okay, let's learn about logical operators. Here we have a little bit of boilerplate code namely two variables and a function. And the imagined scenario here is a course platform, much like Scrimba. And what we're trying to solve is to figure out whether or not a user should get a certificate. That is, whether or not we should call this getCertificate function. Because the deal is, we only want to call this function if two conditions are true. And that is, has completed course. In other words, the user has completed 100% of the course. And secondly, gives certificate. That is, whether or not this is the type of course that makes the user eligible for a certificate. Because you can imagine that very short courses doesn't give you a certificate. The course has to be of a certain size to award you with a certificate. So, what we need to do is figure out how we can check if both of these conditions are true, because then and only then do we want to call this generateCertificate function. You could actually achieve this with the concepts you've learned so far by simply nesting if statements. For example, you could do if has completed course equals to true, and then add the body of the if statement, and then inside of the body you could nest another if statement. If gives certificate equals true, and then you get two ifs inside of each other. And then inside of the inner if, you do generate certificate. Now, if we run this code, you can see, yes, we are indeed generating the certificate. And if we flip one of them to false, we are not generating the certificate, because here, this condition was not fulfilled. So neither of the code lines inside of the body was run. JavaScript just jumped over the entire if statement. However, this is a very clunky way of doing it. Better way would be to actually remove the inner if statement. For now, let's just comment it out. And then inside of the parentheses here, we can add another condition by writing a double ampersand and then the next condition gives certificate equals true. We now move this line, and uncomment this one. Run this code. We see nothing happens because this condition here is false. And with the AND operator, both of the expressions before and after the operator need to evaluate to true for this entire expression to evaluate to true. So if we flip this to true, and run this, now it works. But it's much better to have it on one line. And a little extra thing we can do is actually omit these triple equals true, because now, what does this and this evaluate to? Well, it's simply true and true. And true equals, well, true. But as for now, in order to be explicit about the condition we are checking for, I actually want to keep these triple equals here as well. So one way to read this in plain English is if this is true and this is true, then run this code. Hopefully that makes sense, because in the next cast I'm going to give you a challenge so that you get your hands dirty with this as well. Okay, let's continue on with our course platform example. So in this challenge, you are to imagine that you are writing the code that is to be run after the student has struggled with the challenge for a little while, or maybe the student has clicked a button and signaled to the platform that she is stuck. And we first want to check, has the student solved the challenge she's trying to solve? And has the student any hints left? Because if the student has any hints left, she can go and open those hints. But if she's used all of our hints and she hasn't solved the challenge yet, then we are to run this show solution function and just show her the solution. Obviously, it just logs out a string, but you can imagine that it would show the solution. So your job is to create an if statement that checks that both variables are false. I mean, these two variables. And then if so, run the show solution function. Go ahead and give this a shot, and then I will, of course, show you the solution when you return back to this screencast. Okay, the way to solve this is almost similar to what we did in the previous cast. We'll do if, and then open and close parentheses. And here we need to use a logical AND operator, because we're going to check if both has solved the challenge triple equals false, and the double ampersand has hints left is also false. Then, if the user hasn't solved the challenge and has no hints left, it's time to give her some slack and show this solution. So then we'll trigger show solution like that. Let's run the code. And indeed, this triggers the code because both of them are false. If we try to flip one to true, then the code is not triggered. We're not logging anything to the console, meaning that our logical operator that governs our if statement actually works. Great job. So now that you've learned the AND operator, let's take a look at its close relative, the OR operator. What does that do? Well, it allows you to check if either this condition is true or this condition is true. And if so, the body of the if statement will be executed. So if you're in a situation where we only need one of two cases to be valid, well then you want to use the OR operator. As for this example, it doesn't really make sense. It will now run since actually both of these are true. But if the give certificate is false, it will also run. But that doesn't make any sense because if the course doesn't give any certificates at all, you're not supposed to generate any certificates regardless of the user having completed the course. So let's use another example instead. Imagine here that you're building Netflix and you've just launched this amazing new documentary, The Fire Festival. I don't know if you've seen this, but it's truly amazing, about a guy who creates a festival that aims to be the celebrity hotshot festival of the world, but just becomes a disaster. It's really good. After this has been launched, you probably want to recommend it to a ton of your users. And what you want to do is you want to check if the user likes documentaries or if the user likes startups. They don't have to like both, but if they like one of these themes, then most likely they will enjoy the Fire Festival documentary. So I want you now to try to use the OR statement, that is the two lines you can see here. You can copy them if you want, if you don't know how to get them from your keyboard. And you're going to use this to call recommend movie if either of the variables, that is the likes documentary or like startups, are true. I'm pushing you out on thin ice here. I haven't written a complete OR statement for you, but it works in just the same way as the AND statement, so I think you can do it if you just give it a shot. And if you don't, no worries, I will show you the solution afterwards as well. Okay, let's do this. We'll do let likes documentaries, set that to true, and we'll do let likes startups, set that to false, for example. And if likes documentaries, if that is true, or if likes startups is true, well, then we want to recommend this movie, like that. Running the code, we can see we are recommending the movie, even though this one is false. Flipping both of them to false. Now, if I run the code, nothing happens because at least one of them needs to be true, this or this. And if we make both true and run the code, then of course, if both are true, then one or the other is also true. So that would satisfy the condition. Great job doing this challenge. Let's keep up the pace and move on. Now you are going to take what you've learned about the logical AND operator and modify this new card function so that you only allow the player to get a new card if she is alive and does not have blackjack. So those are the two conditions that need to be filled for you to actually run this code. So give this a shot, and I will of course show you the solution afterwards as well. Okay, so the way to do this is if, open and close parentheses, and then I'm going to actually just open the body of the conditional and paste in this code. And when are we going to run this code? Well, she has to be alive. I'm going to do is alive. And then if that equals to true, that's the first condition. And the second condition, which we also want to be true since we're using this logical AND operator, should be that the has blackjack should equal to false, like that. If is alive is true and has blackjack is false, then the dealer should be willing to give the player a new card. So let's try this. We'll start the game. 15, new card. 25, you're out of the game. Let's try to ask the dealer if we can please get one more card. Oh, nothing happens. It works. Brilliant. Really good job doing this challenge. Okay, so our blackjack game is almost complete. There's just a tiny little feature I would like to add as well. Because if you've ever played online blackjack or poker, what you normally see is your own name and your credits or your chips somewhere on the screen. So what I mean by that is something along the lines of this. Like that. So you see your name and how many credits you have or chips or whatever. And this is nice because then it's possible to later implement the concept of winning, of increasing your chips, and of losing as you are betting or playing rounds. These are critical components of any blackjack game. However, I wouldn't want to hard-code it in the HTML like this. We of course want to represent this data in our JavaScript, as that gives us the ability to change it. Now I'm going to just show you how we could do this to begin with, by first giving this an ID of player-L and removing the contents of it. And then in the JavaScript, we could do let player name equals pair and let player chips equals 145, for example. And then we could grab the element player L equals document.get element by ID, passing in the ID we just created. And then do the playerl.text content, which you know by now. Your name, colon, and a space, and then a $sign, and then plus the player chips, like that. If we now run this, you can see, yes, that we render it in the exact same way. However, now we've come into a situation where two values that are inherently connected together, like the player and his chips, which currently live in two different variables. What would make more sense in this situation would be to somehow combine this into a single unity. And that is where so-called objects come into play. That is another data type which resembles arrays a little bit, but they are also different in some fundamental ways. But they are kind of also buckets where you store data. So in our case, we would perhaps want to create a player object in which we can store both the player's name and the chips. So I'm going to show you how to do this. You might feel a little bit confused as you see it, but over the next few casts, you're going to practice objects yourself. So what I'll do, I'll write let player equals open and closed curly brackets. You've seen these before. They're used often in JavaScript. But when you see them in a context like this, after the assignment operator, they mean that we are creating an object. And inside of here, what I essentially want to do is add this data right here. However, you can see that something is wrong here with all these red lines. And that's because the syntax for creating items inside of our object is different from how we define variables. First of all, we don't use the let keyword in front of the names. And secondly, we replace the assignment with a colon. And thirdly, just as we have in arrays, we separate the items with commas, but we don't do that on the last item. Finally, here it would make sense to omit the player, as we've already used that name as the name of the entire object. So we can just rather do name, and I'm not going to capitalize it, and chips, like that. Now we have taken our two variables and grouped them together in this little bucket, which we are calling player. And the way we now can refer to these values, pair and 145, is by using the object name, player, and then the given key. And that is the name, because this is called a key, and its value. So name is the key, and pair is the value. Also, chips is a key, and 145 is a value. So to replace player chips with a reference to the chips inside of the player object, we'll instead do player.chips. If I run this code, you can see we get the exact same result. You're probably a little bit confused now, so don't worry if you think this was hard. Over the next few casts, you are going to practice objects for yourself so that this becomes muscle memory and second nature to you. Let's move on. One way to think of objects is that they give you the ability to store data in depth. And with that in mind, we'll know that objects are so-called complex data types, or also called composite data types, because we use numbers, strings, booleans, even arrays in order to compose objects. So they often store quite a lot of data. And they can even store objects within objects. That kind of nested data structure, it's not something you're going to think about now. For now, just think of it as key value pairs. And let's look this through the lens of a real-world example, because that's always easier. So here on Scrimba, we represent our courses as objects. Because here you can see the CSS Grid course, actually the very first course we launched back in the days, and it has a bunch of different data. For example, it has the title, the number of lessons, and the creator of the course, the length of the course, and the level of it. So let's actually translate this course into JavaScript, into how the data structure actually looks. So do let course equals open and closed curly brackets. Start with the title, like that, title, colon, learn CSS Grid for free. Now we have one key value pair, title is the key, and the string here is the value. Then the lessons, that is natural to represent as a number, so it was 16 lessons. The creator, which again is a string, that. And then we have the length, which, while it says 1 hour here, that's actually not how we represent that data in our database and thus in this object. Break it down into minutes. So perhaps this course is actually 63 minutes. But as for the user interface, we don't go into detail that much. We round it to the closest hour. And finally, there's the level, and here it says intermediate. But that's also one of those cases where the data in the user interface differs slightly from the data in the database. So our levels are represented from 0 to 3, where 0 is for complete noobs and 3 are the advanced courses. So the intermediate course, you can see here, we type out intermediate here if this value is set to 2. Now, you don't have to worry about how our design and what we say to the user differs from the underlying data. It's just something I wanted to give you a little heads up about, because it's very normal in real-world code bases. Now, it looks like we're kind of done here, but we're actually not, because there's a lot more data for a course actually than what's represented here. For example, whether or not it's free or paid, that's a boolean, so it's either true or false, like that. Is free, true, and this course is indeed free. And we also have tags for courses. And that's an array, because we want to have the ability to add multiple tags to one course. So we need a complex data type here as well as the value of this tags key. So for example, this CSS Grid course has the tags HTML and CSS. So this is a very real-world example of an object. Now, if we want to access any of these values here, for example, the length, we do that through something we call the dot notation. Course dot length, like that. Console log out this and run the code. You can see that we log out 63. So course dot length gives us back 63. And you've used this dot notation quite a lot actually, up until now. And even though you probably haven't been aware of it, you have been using objects all along. Like, what are we doing here? Console.log. What kind of data type do you think the console is? Well, it's an object. And just to give you one more example, let's say we want to log out this array here. Well, then we simply do course.tags on the code. And when we open the console, we can see that we are logging out an array, because this entire array is the value that we get back when we ask for the tags. Now, one thing I want to point out before we move on, that you can replace this dot with an open square bracket and then add a closing square bracket and then turn the key name into a string. This is called bracket notation. If we run the code, we get the exact same thing back. Now, there are reasons for why you sometimes want to use bracket notation, but we're not going to get into that right now, because in the foreseeable future, you are not going to end up in a situation where you have to do that. So I'm just going to tell you now to use the dot notation. It's simpler, it's shorter, less code to read, less code to write. It's very understandable, and it's actually what most developers prefer to use if they get to choose. So now I've been talking for far too long. I want you to write code, of course. This is Scrimba. That's what we're all about. So in the next cast, you are going to write your own object. I'll see you there. One thing I like to do if I'm bored is to search for epic places to live on Airbnb. For example, castles. Like this wish list I came across right here, which contains a bunch of more or less affordable castles to rent across Europe. So for example, this really neat looking castle right here only costs $190. I mean, that's what people pay for like 10 square meters in a hotel room in central London. So pretty cool that you can rent a castle for that same price. But anyway, the point being that these listings here on Airbnb most likely take advantage of the object data structure in order to store all of the data that they need to present to the user. So this can also be a great exercise for you so that we can build up that object muscle memory of yours. So I want you to basically create an object that represents an Airbnb castle listing. It should contain at least one boolean, one string, one number, and one array. It can contain a bunch more if you want to go above and beyond. However, that's the minimum requirement. And at the end, I want you to log out at least 2 of the keys using the dot notation. So go ahead and do this right now. Okay, hopefully that went well. Let's do this together. I'll do let castle equals, open and close brackets. We can use the title. Live like a king in my castle, like that. As for the number, I think the price, it's very natural to use. Price, $190. And what about the boolean? Which components here naturally lend themselves well to be using a boolean data type under the hood? Well, I think the fact that 2 of these are superhosts and the third is not points to this being a suitable piece of data for the boolean data type. Because you're either a superhost or you're not. So, is superhost, and this one happened to be true. And then finally, there's the array. What kind of data here would it make sense to place inside of an array? Well, it could be that these kind of bullet points here are arrays that are pulled out of the underlying data and are kind of the featured selling points that Airbnb wants to list out. Or, actually, you can see that there's multiple images here if you see this carousel indicator. So the images is very natural to have inside of an array. And also the reviews, that's definitely a list of many items. So it doesn't matter what you choose, or if you choose something completely different. The point is just that I wanted you to write an array inside of an object. So I'm going to choose images like that, make that an array, and here we probably have URLs to the specific images. So it might be img/castle1.png, img/castle2.png, and so on and so on. And I won't bother writing anymore. Now let's log out 2 of these using the dot notation. Console log castle.price, console log castle.isSuperhost. We'll run this, and indeed, we print out 190 and true to the console, meaning we have completed the challenge. Great job solving this one. Let's move on. Okay, welcome back. Now it's your time to render out the player's name and his or her chips on the page. So it's a 4-part challenge. First, you are to create a paragraph with an ID of player L. Then you are to move over to the JavaScript and create the player object here at the very top. And you are to give it 2 keys, name and chips. Then you are to move down to where you are grabbing elements from the DOM, and then grab hold of the player L paragraph and store it in a variable called player L. Then you are to render the player's name and chips inside of player L. So, pretty big challenge. But you've seen me do it before, and you've practiced how to work with objects, so I think you're going to nail this one. Give it your best shot, and then I will show you how to do it as well afterwards. Okay, hopefully that went well. If not, no worries, let's do it together. First, we'll do a paragraph here, and we'll give it the ID of player-L, like that. Nothing happens because it's empty. Moving over to the JavaScript, we are to create the player object. Let player equals, open and close curly brackets. We are to define its name. In my case, pair. Use a comma to separate the items. And then chips. Let's say I have $200 in chips right now. 3, grab a hold of the player L paragraph and store it in a variable called player L. Okay, we know how to do that. Let player L equals document.getElement by ID, passing in the player-L, which is what we created right here. At this point, let's console log out player L, and indeed we are fetching it from the DOM. Finally, we are to render the player's name and chips inside of player L. We know how to do that as well. Player L.textContent equals, and here we have to concatenate the string and dig into the object to find the correct values. So we'll start with the player.name plus, we're going to have a colon and a space and then the $sign in front of the chips, and then do plus again, player.chips. Now, this is all set up. Let's run the project, and there we go. We have rendered it out. Great job solving this challenge. Now that you've learned about objects, I want to tell you about a specific coding pattern that we've actually been using quite a lot here, but that we aren't going to implement from scratch ourselves in this module. But since we still are exposed to it, I want you to understand what's going on under the hood. And that pattern is to create functions inside of objects, something which we also call methods. Because let's say that, for example, we create another key here, which is say hello, and then a colon. And then as the value, we'll actually write a function, like this. We won't give it a name. It'll just be an anonymous function. And inside, we'll console log JSON. That's howdy in Norwegian. And now, if we want to invoke this function, we'll do player.sayHello, and then open and close parentheses. If we run the code now, you can see that indeed we are logging JSON to the console. And now, the reason I wanted to show this to you is because don't you think this syntax looks a little bit familiar? Like first a variable, then a dot, and then a function that you are calling with the parentheses at the end. Because actually, that's the exact same thing we're doing here when we're saying document dot get element by ID and the parentheses. And here we're also passing in a value, but it's essentially the same thing. And also here down at math dot random, also the same thing. Math is an object and random is a function on that object, also called a method. And even our good old friend console.log is the exact same thing. Object with a method. So this is not something we are going to implement ourselves in this module, but I just wanted you to be aware of that, so that when I speak about methods, you know that they are simply functions that are attached to objects. So with that, let's move on. So you have built your very first JavaScript game. Congrats with that. This is perhaps the first of many games you're going to build, perhaps the start of a career as a game developer. I don't know. Anyway, give yourself a pat on the back. You have learned a ton. And actually, let's do a little recap so that you remind yourself about all the awesome things you've learned throughout this section. One thing which was key to our app and is key to basically every web app out there is the arrays. We defined a card array, and also we reassigned the array down in the start game function where you defined it with items. And then all the way down at the new card button, you also pushed to the array. So you are starting to get some serious array skills. Also, we worked with objects. Up here, we created our player object, and the object, as you remember, contains key value pairs, and it's also a data type that is used in basically every single web app out there. The third data type you learned was booleans, namely the true and false for the has blackjack and is alive variables. We flipped them around, so we set is alive to true down here and has blackjack set to true down here, and thus creating kind of a state for our game. This brings us to the next important concept you learned, which is the if-else statements that wrapped these booleans and so many other things. This is key. You cannot build apps without these kinds of conditional statements. Both the if, the else if, and the else are absolutely key in any programming language. And in order to make these if-else statements work, we used comparison operators. That's these guys in here, less than or equal to or triple equal. They helped us define the conditions as to when we wanted to render the blocks of code in the if-else statement. Moving on, we also did logical operators. The AND operator, which checked that both this condition and this condition was true in order for us to run this code in the block of the if statement. And something we also learned was the for loops. It was here in the render game function, where we used the for loop to loop through our cards array and render out each of the cards. Again, for loop is just one of those foundational things in programming, because so much of programming is evolved around looping through data and doing things based upon the data. Whether that's rendering it out, making calculations, sending it off from a server to a client, or just summing it together, for example, it doesn't matter. It's just something you'll do again and again, so I'm really happy that you've learned it as early as now. Another useful tool you've learned is the math object. That allowed us to create this getRandomCard function by using math.random, which gives us a number between 0 and 1, and math.floor, which basically floors the number to the nearest whole number moving downwards. And you built upon your further knowledge of functions and learned how to use return statements in functions, because in this getRandomCard we had to return values, and that's something you didn't know before this section. There's still more things to learn about functions, so we'll definitely continue on with functions in the Chrome extension we're going to build a bit later, but for now just be proud about the fact that you've at least come to the point where you can return values in functions. That's a big, important step. So, with all of these things learned, I completely understand if you feel that you're a little bit on shaky ground here and that all of these names basically just confuse you even more. I don't think you should worry about that. I would have never remembered the difference between comparison operators and logical operators when I learned JavaScript. What they are called doesn't really matter. The important thing is that you know how to compare two variables, for example, or that you know how to create a true or false variable. Whether that you call them booleans or true false isn't something you should be too worried about right now. So even though this might look scary, try to not let it scare you. Just focus on coding as much as you can, because over time these concepts will mature in your mind and become second nature. And actually, on that note, you are going to get some practice right away, because before we jump on to the final project, the Chrome extension, I'm going to throw a few challenges on you just so that we're sure that you really understand these concepts and that you build out that ever so important muscle memory. So let's go ahead and do that right now.